You know that iconic scene in Jurassic Park? You know, the scene where the T-Rex attacks the kids and roars like... Well, how would it make you feel if it was covered in feathers? Like a big emu. Hi, I'm Danielle Dufault and you're watching Animalogic. Eutyrannus huali is a newly discovered tyrannosaur species found in northeastern China that lived 60 million years before T-Rex. Multiple individuals were found with preserved remains of monofilamentous feathers. Scientists say it would have been like touching long, thick fur, similar to the modern emu. This is the largest feathered dinosaur ever found, and since T-Rex is related to this new species, chances are good that T-Rex was feathered as well. Sorry guys, but your scaly Godzilla monster is looking less and less likely. If you thought that puberty was a weird time for you, T-Rexes, who lived 66 to 68 million years ago, had a much weirder time. Starting around age 14, they would gain 600 kilos a year, or around 2 kilos a day until the age of 18. After which, they would plateau until they died, which typically was around 30. Their exact height is difficult, if not near impossible to measure, due to the incompleteness of the fossils, but best guesses put them at around 12 meters in length and at a height of 4 meters at the hips. Starting as a 1-ton lizard and ending up as a 7.7-ton powerhouse, T-Rexes lived fast and died young, and in order for them to grow so exponentially, they had to eat a lot. According to XKCD, one of my favorite webcomics, if a T-Rex was released into the world today, a la Lost World, it would need to consume one human every couple days to sustain itself, requiring around 40,000 calories per day. Alternatively, they estimate it could keep itself going on 80 Big Macs every day. No big surprise, the T-Rex's diet mainly consisted of other dinosaurs, and there's even evidence to suggest incidences of cannibalism. But when Steven Spielberg made Jurassic Park in 1993, there was no proof suggesting that the Tyrannosaurus Rex actually hunted live prey. Some scientists even thought that they may have been scavengers, feeding on the carcasses left behind by other meat eaters. A recent discovery by researchers suggests differently, and a T-Rex tooth that had been lodged in the tail vertebrae of a hadrosaur may be the smoking gun. The T-Rex fed with a bite and pull action, effectively tearing flesh and crushing bones in its powerful jaws. By examining the bite marks left in the fossilized pelvis of a Triceratops, researchers believe that Tyrannosaurus could bite with up to 3,000 pounds of force. This further supports the suggestion that they hunted and killed their prey. I mean, why would a scavenger need to bite with the force of a small truck? In order to reach the tasty, meaty neck muscles of the Triceratops, researchers believe the T-Rex would actually decapitate their prey, using their powerful jaws to grasp the bony frill and, well, pull and pop their heads right off. Basically, it's the Cretaceous version of popping open a beer. Using statistical analysis, scientists calculated the top running speeds of 5 meat-eating dinosaurs. The T-Rex came in dead last. With a top speed of 29 kilometers an hour, the T-Rex just barely beat out a human. Yes, sadly, we'd still get eaten if we don't outmaneuver them, but the Tyrannosaurus is certainly not as fast as the Jeep in Jurassic Park. So another Jurassic Park myth. In the iconic scene, Dr. Grant says, "Don't move. T-Rex can't see us if we don't move," implying that T-Rex vision is movement-based, but it's just not true. Can you imagine T-Rex bumbling around, running into trees? Due to the front-facing position of the eyes, it had an incredible binocular range of 55 degrees and could see with reasonable clarity up to 6 kilometers away, which would have been even better than hawks. All in the family, right?
Don't let their cuteness fool you. Beyond their adorable frolicking among the waves, which has made us fall in love with them since times immemorial, there's a ruthless world. The life of a dolphin is dangerous and violent, and often its worst enemy is another member of its species. This is the dark side of dolphins. The hunting of dolphins is immoral, and whoever willingly devises destruction for dolphins can no more draw nigh the gods as a welcome sacrificer, nor touch their altars with clean hands. Ancient Greek poet Oppian might have gone a bit over the top when he described how revered dolphins are to us humans. But even for humans today, dolphins have a special place among the more sentient animals. In ancient Greece, dolphins were depicted as people rescuers, sharing many positive human traits, like friendship, sociability, goodwill, and playfulness. Over the centuries, as we've studied them more closely, we've discovered that dolphins also share our less desirable human traits, like individualism and even violence. Dolphins comprise 36 species that can be found all around the planet. Like humans, dolphins have complex social systems and are highly individualistic. This sense of me first, as we know ourselves, can sometimes result in a lot of sketchy behavior. Dolphins are apex predators that hunt both for necessity and fun. Their strategies for swarming and gobbling up their prey are well documented. From creating mud clouds in the water to confuse prey, to bum-rushing fish onto shore and snapping them up on the sand. We are always discovering new ways that dolphins have found to secure their snacks. What is more surprising is when we uncover dolphins harming or even killing for sport. Bottlenose dolphins have been seen killing the significantly smaller harbor porpoise. The scientists studying this behavior have yet to determine the why behind it, but it seems that competition for resources isn't one of the reasons, as there isn't much overlap in the diet of these two species. More likely, these dolphins are maiming and killing porpoises to maintain their fighting skills, or much more sinisterly, just because it's fun. And porpoises aren't the only species that dolphins snag for their entertainment. Dolphins have been known to use turtles, pufferfish, and octopuses as living toys. They've even been observed using pufferfish to get a little bit high. When stressed, pufferfish release a neurotoxin powerful enough to kill. But when used sparingly, it can make dolphins pleasantly blissed out. Dolphins have even been observed passing the puffer around a group to get high together, and staring at their own reflections in the water's surface above. While they may be vibing during recreational time, when it comes to reproduction, dolphins aren't quite so relaxed. Sex and aggression in dolphin society often go hand in hand, and male dolphins are especially hostile in their interactions with females. In a behavior called herding, a group of 2 to 3 males are known to surround a female who is unwilling to mate, capture her, and prevent her from mating with anyone else. This imprisonment can go on for weeks at a time. All the while, they're trying to coerce her into being receptive to their advances. This is a particularly brutal reproductive strategy to ensure that the male who successfully mates with her will carry on his line. But females also have their own strategies to avoid becoming impregnated by a male they don't like. Female bottlenose dolphins have evolved complex spiral-shaped vaginas, with folds leading to dead ends. If a male forces himself upon her, she can rotate her body, causing him to spill his seed in the wrong direction. She can then swim off to mate with a male she picks herself. Sex among dolphins isn't always so violent, thankfully. Australian humpback dolphins have been seen courting females by bringing them enormous sea sponges, all while singing and dancing. These visual and auditory displays, along with the gift of a hefty sponge, could be meant to convince the female that he would be a strong and virile partner. The less romantic interpretation is that he's showing off just how strong he is, as a display of dominance to coerce her into mating. And now we're back at violence, which I guess is never far from the surface with dolphins. Remember those murdered porpoises? They were killed at the height of the breeding season, when testosterone in male dolphins is at its peak, and their most ferocious tendencies are on display. During this time, dolphins have even been known to have the blood of their own brethren on their flippers. Infanticide happens among dolphins when males kill the young of a female they didn't mate with. This reproductive strategy ensures that the female will become fertile again in a few months. quickly opening up the possibility of a successful pairing for that male. In 2009, a scientist in Scotland observed an attempted infanticide when a male charged into a mixed group of bottlenose dolphins, grabbing a newborn calf and attempting to kill it. The mother and others were able to pull the baby away, but it was found 8 months later, beached with serious spinal injuries. These kinds of aggressive attacks against newborns may explain why spinal deformities are common in that dolphin population. When it comes to dolphin sexual aggression, even other species aren't safe. Not even humans. There have been countless reports of male dolphins trying to use humans to scratch a biological itch. One coastal town in France even introduced a swimming ban in response to a lonely dolphin named Zafar that started harassing swimmers. Much like us humans, touch is an important part of bonding and communication in dolphin society. Dolphins will often touch each other's flippers or brush up against each other as they swim alongside. The need to touch sexually is also part of reinforcing bonds among dolphins, even between same-sex individuals. The fact that Zafar was an outcast from dolphin society was likely a contributing factor to him seeking contact, sexual and otherwise, from the humans who were drawn to his gregarious nature. While dolphins may engage in some seriously sketchy behavior according to us, hyperbole aside, they can't be viewed through a human moral lens. Instead, we could use these complex creatures as a mirror to hold up to ourselves in an effort to examine our own darker sides.
Today, we're talking about organisms that show little or no signs of biological aging. These are the immortals. We are a species obsessed with aging. We're constantly trying to battle the gray hair, wrinkles, and especially disease and mental and physical deterioration that comes with getting older. While it may be straightforward for us humans, on a scientific level, aging is extremely difficult to define and is far from universal. Dozens of theories for aging have been floated to explain it in evolutionary terms.
Certainly, the human race hasn't been here long enough to see a star go through its birth processes, its coming of age, its maturity, and its death.
Negligible senescence is a real mouthful, so let's break it down. Senescence is the trend on a cellular level, where individuals of a population increasingly experience disease and deterioration as they age, leading eventually to death. Negligible here means that the rate of disease and death in relation to age isn't statistically significant. What that means is that the risk of disease and death is stable, or, in some organisms, even decreasing over time. Sometimes, establishing senescence is difficult because it's hard to study long-living organisms in the wild. For example, we know that Galapagos tortoises are the longest-living reptile. Their lifespans exceed a century in the wild and almost twice as long in captivity. But the jury is still out on if they actually age or not. So let's take a look at some of the enduring organisms whose status of negligible senescence is still under investigation. For that, we need to dive deep into the ocean to see the longest living vertebrate in the world, the record-breaking Greenland shark. Greenland sharks can live for hundreds and hundreds of years in the Arctic and subarctic. They're actually the only species to inhabit these icy waters year-round. One theory as to how these sharks can live so long is that they've adapted to the cold by slowing down their metabolism, which slows down all other processes as well. Greenland sharks do everything slow. They grow a minuscule 1 centimeter a year. They swim just 3 kilometers an hour. They only reach sexual maturity after about a century. Their unhurried pace of life means that aging is slow too. Not much is known about the Greenland shark, as they're extremely tricky to observe in the wild. The first photograph of a Greenland shark wasn't even taken until 1995. Now that we're firmly deep under the sea, we've reached the depths of agelessness. Hydra vulgaris. These tiny palm tree-looking cnidaria measure just 1 to 3 centimeters in length and are 1 millimeter wide. They're also virtually immortal in lab environments. Every 20 days, this tiny everlasting invertebrate completely regenerates itself, thanks to its stem cells that are in a continuous state of renewal. From what we've seen, and we've been studying its eternal qualities since the mid-1700s, it doesn't age, and it doesn't die. If you cut pieces of a hydra off, it will simply regenerate. That's why it was named after the serpent in Greek mythology, where 2 heads grow back with every one that's chopped off. Even more impressive, if you scramble the cells of a hydra and squish them into a ball, the cells will rearrange and a new hydra will grow. The only things that kill a hydra in the wild are extreme weather events, disease, being gobbled up by predators, and Captain America. Recent studies have shown that they do slow down their asexual reproduction over time, which is a sign of aging, but research is ongoing. There is just one creature that one-ups the hydra in its avoidance of the slow march towards death, and that is the appropriately named immortal jellyfish. This is the only species that we know of that can be called truly biologically immortal. This small jellyfish, which lives in waters all around the world, can actually reverse its aging process and revert to an earlier stage of its life cycle if it experiences stress or injury. Imagine being able to Benjamin Button yourself back to an embryo at the smallest inconvenience. This all just goes to show that the concept of senescence is as slippery as an immortal jellyfish. So let's take a look at some of the enduring organisms whose status of negligible senescence is still under investigation, like the ocean quahog, which can live to be at least 400 years old. One theory about how bivalve mollusks live so long is that they have high antioxidant capacity, which slows the aging process. Just take a look at any of the labels found on anti-aging products on the market today to see how us humans have tried to bottle that power.
While it may not be necessary for all of you, some girls use a lubricating cream or lotion to prevent skin roughness or chapping. Expensive creams and powders, however, aren't necessary. A healthy skin can be kept attractive with only a few simple preparations.
Rough-eye rockfish have also been recorded to live 140 years. We know this by measuring the rings of the small bones in their ears, called otoliths. Just like a tree's rings, the otolith gives researchers an exact read on just how old a fish is. Despite these potentially advanced ages, scientists are still trying to determine if rough-eye rockfish actually experience negligible senescence. Despite being the longest living arthropod, and what the memes say, American lobsters are not immortal, and they do experience senescence. They do, however, have the immortality enzyme, which is responsible for their long lives.
But now the lobster tries to get even. He demands cool, damp moss in which to live, and he refuses to live long if he doesn't get it.
This enzyme, called telomerase, is present in many lobster cells and allows the cells to keep dividing so that the lobster can keep growing and regenerating.
While the lobster is known as one of the world's greatest food delicacies, he is also famous for being just about the world's dumbest creature.
Human stem cells contain telomerase too. Lobsters grow throughout their lives, molding their shell and building a new one with each growth spurt. The theory is that this cycle costs the lobster a lot of energy. So, as they age, this growth and molding slows down until the cost becomes too high and the lobster dies of literal exhaustion. This happens to an estimated 10 to 15% of lobsters. The other 85 to 90% end up melted in butter.
He may be dumb, but as the main course for a delicious dinner, he's the tops.
Freshwater pearl mussels exhibit many characteristics that are typical for negligible senescence. They grow throughout their long lives, which can be over a century. They don't lose their ability to reproduce, and there are no noticeable differences between young and old individuals. The probability of pearl mussels dying does, however, increase with age. One study suggests that pearl mussels are an example of why negligible senescence isn't actually a thing. Our journey through immortality continues high up in the Rocky Mountains with the Great Basin bristlecone pine, the longest living non-colonial plant in the world. The oldest individuals that we know of are over 5,000 years old and show no signs of slowing down. Another everlasting tree is the quaking aspen, which, unlike the bristlecone pine, is a clonal colony tree. This means that all individuals in an aspen stand are genetically identical and just part of one huge underground root system. These aspen groves can live to be thousands and thousands of years old. Aspen are coated to survive. A thin layer of their bark photosynthesizes, so they can continue to grow even in winter when all other deciduous trees have gone dormant for the season. Aspen can stand drought, fire, and basically anything you can throw at it, and only need one thing to survive: lots and lots of sunlight.
We know that green plant pigment, chlorophyll, is produced in plants only when they are exposed to sunlight. Keep a plant in the dark, and the leaves lose that rich green color. They become pale, and the plant slowly dies.
As the roots spread, they search for the best sunny spots, and once found, they'll spring up new trunks. Even if an individual tree is killed by a browsing animal, the other trees and the underground root system are unaffected. Losing a tree is like clipping a toenail. And if proper sunlight is blocked by other trees, the roots can lay in wait for a century or more until conditions improve. While individual trees only live about 150 years, one colony of aspen in Utah's Fish Lake National Forest is estimated to be 80,000 years old. Ginkgo biloba trees are also able to live for thousands of years, and when studied on a cellular level, show no signs of senescence. A study that compared a range of ginkgo trees, aging from 20 to 600, found no difference in their efficiency of seed germination, photosynthesis, nor disease resistance. The gene activity was the same, and the researchers couldn't find any evidence of programmed death. When ginkgos do die, it's usually from external factors like disease, storms, fire, and logging.
Cormorants are birds from hell. Satan in disguise, according to John Milton in Paradise Lost. Today, many still see them as pests and ecosystem destroyers. And yet, they have a beautiful side. They're amazing fishers and divers, and their presence signals a healthy ecosystem. So what's actually going on with these strange birds? These are the cormorants. The cormorant has been maligned for centuries. That is possibly because of the ominous pose they strike while perching in a tree, or the way they stare at you with their beady little eyes, or because they represent greed due to the amount of fish they eat and the size of those fish, which sometimes look impossibly ambitious for such a slender bird. Or maybe because to medieval old heads, a bird that swam with the fishes seemed unnatural. And yet, despite the bad rep, they have spread all over the world. So what are they, and what is it that makes them thrive? The cormorants are members of a family of over 40 fish-eating species. Some are known as shags because of their shaggy hairdo and fancy crests, but they're really just extra stylish cormorants. All of them live in coastal regions and hunt by diving into the water and swimming at depths of up to 40 meters. Just look at them go. This swimming behavior is easily the coolest thing about them. So let's dive into how they manage to be the best freedivers in the bird world. There are a few different hunting strategies depending on the species, but generally, cormorants will seek prey from high spots or by floating on the water like a duck. And then, once they spot prey, they'll dive down to get their catch of the day. Their webbed feet propel them underwater, like the fins of a scuba diver. Their plumage isn't waterproof, unlike most waterfowl species. They actually want to get wet so that they can sink more easily and dive to deeper areas. Then they'll secure their catch with their long hooked bills during dives that can last over a minute. The last part of the process is flying up to their favorite tree or post and standing on a tall perch and spreading their wings to dry them in the sun. This is such a simple but perfectly finessed strategy that it has helped them take over the world. Virtually every region of the planet has a dominant cormorant species, and many others who eat slightly different diets. In North America, the double-crested cormorant is king. There are over 2 million of them ranging from Alaska to the Caribbean. The entire Atlantic and Pacific coasts are peppered with them, and a large number of them breed along the shores of the Great Lakes. We'll come back to them later. Just directly south of the double-crested cormorant's realm lives the new tropical cormorants. These birds thrive from the jungles of Mexico to the tundras of Patagonia. And the great cormorant has the largest distribution of all, living in coastal waters from Greenland to New Zealand. Even in Antarctica, the usual exception to animal distribution, you can find Antarctic shags, which start to look a little penguin-y with white bellies and black backs, possibly to be less visible to marine predators like leopard seals. The fact that you can go to basically any body of water in the world and find these guys can be a blessing or a curse, depending on who you ask. There is a history of associating black animals with evil spirits and the macabre, and these birds carry those connotations in their name. Cormorant is a contraction of Corvus marinus, the raven of the sea, with ravens being synonymous with uncleanliness, bad omens, and harbingers of death. In more modern and practical terms, cormorant colonies are often made up of tens of thousands of birds. They eat a lot of fish and destroy tree canopies due to their nesting practices, and harm ground vegetation due to the acidity of their feces. Fishermen perceive them as competition for fish, and they take a toll on fish farm stocks. They're also incredibly loud, grunting and croaking in cacophonies that can be heard from hundreds of feet away. And they are kinda stinky. They regurgitate as self-defense and also puke pellets, kinda like owls, with the indigestible parts of the fish and crustaceans they eat. But really, this is just an animal being an animal, eating what it can and protecting itself in any way possible. This hasn't stopped culls all over the world. In the US, over 100,000 cormorants are allowed to be killed every year, and thousands of eggs are destroyed unofficially. There is a lot of controversy about their actual impact on fisheries, but their negative impact on trees is unfortunately true. My hometown of Toronto holds a colony of over 80,000 double-crested cormorants. Their numbers have exploded over the past few decades, and measures had to be taken to protect the trees along the shoreline. So, we headed down to the shores of Lake Ontario, home to dozens of bird species, and an amazing place to see wildlife. So we just got to Tommy Thompson Park, and first thing we see is a group of like 40 swans. We couldn't help but stop by and see what's up. Getting to watch their mating dance was amazing. But they weren't even the main reason that we're here. They just happen to be some of the incredible creatures that inhabit this area. What we're really here to see are cormorants. They have a nesting site nearby and we're making our way. Finally, we made it to the nesting grounds, where we met with one of the experts managing the local cormorant population.
I'm Andrea Creston, Senior Project Manager with Toronto and Region Conservation Authority, and today we're here at Tommy Thompson Park on the central Toronto waterfront. Tommy Thompson Park is home to the largest breeding colony of double-crested cormorants in North America. The population crashed in the mid-1900s due to impacts of DDT, which was a chemical that was prevalent in the ecosystem. It caused a thinning of their eggshells and they couldn't reproduce. Once that chemical was banned and was cycled out of the ecosystem, the population was able to start a recovery, and we saw cormorants arriving in Toronto in the early 1990s. By 2007, cormorants were nesting on 3 of the 4 peninsulas here at Tommy Thompson Park. They had impacted 24% of the forest canopy within the park, and they'd also started a natural ground nesting colony, which doesn't impact the trees.
Promoting the cormorant's natural ground nesting behavior is a humane and effective strategy to protect tree canopies.
So through the strategy, we discourage nesting in healthy trees, and we encourage the cormorants to nest on the ground. By discouraging them to nest in the trees, it maintains the health of the trees and preserves the tree canopy for all other species within the park.
But how do cormorant nests destroy tree canopies?
Tree nesting cormorants negatively impact the trees that they nest in. First, cormorants have very acidic feces. So when they are nesting in the trees, the excrement rains down, it covers the leaves, so the trees can't undertake photosynthesis as well as they should be able to, so less energy production. Also, the excrement lands on the ground and it changes the soil chemistry. This reduces the amount of nutrients that the trees can absorb, which further reduces their health. In addition, cormorants are compulsive nest builders. They like to build really, really large nests, and these nests become very heavy. So as the tree declines in health, these heavy nests put too much pressure on the branches, and the limbs and branches start to fall from the trees.
Right now, the cormorants are on their southward bound migration and have left their ground nests. This is the only time we have access to this area. The nests are empty, but we can still learn a lot about them based on what they leave behind. We're at the nesting site for the cormorants, and it does look like they have finished for the season. But now we get to explore their nests and what they've left behind. Unfortunately, ground nesting makes the nests more vulnerable to predators like coyotes and raccoons, and some cormorants naturally prefer to nest in elevated spots. So, the Conservation Agency has built them these structures, nicknamed cormdominiums. Cute. For cormorants to nest more comfortably according to their natural nesting preferences.
So the distance between the joints on the nesting platform has been designed based on the ideal distance between nests on the ground. And so on the ground, it's about the average distance between nests is 41 centimeters, which is about the length of 2 necks. So if a cormorant is sitting in one nest and its neighbor is in the nest right beside, the two can come beak to beak, but they're not going to cross each other. They each have their own individual territory and can happily coexist in the colony.
There is some opposition to the birds, mostly because of their perceived effect on fisheries. But studies here have shown no negative effect of cormorants on the fish stocks. They seem to eat mostly an invasive fish species called the alewife, and yet, these misunderstood birds are hated by many. On the flip side, humans have utilized cormorants for their fishing abilities for centuries. Chinese fishermen use them to this day, although mostly as a tourist attraction. But in the past, this type of activity has existed in Lake Titicaca, the Mediterranean, and Japan, as far as we know. The cormorants are unfortunately captive and forced to regurgitate their prey. But at least in these areas, they're seen and appreciated for the beautiful and efficient fishers they are. Dinosaurs ruled the Earth for over 100 million years and then disappeared seemingly overnight. It was an Earth-shattering event that was close to extinguishing life forever. But how did so many other species survive? This is a moment-by-moment account of one of the darkest events this planet has ever experienced. The last day of the dinosaurs. We don't know what time or day it was. Probably a Monday, 66 million years ago. Some of the most famous dinos were slowly starting their week. T-Rex, Triceratops, and Ankylosaurus were looking for their next meal. Pachycephalosauruses were headbutting each other, and over in the ocean, mosasaurs were terrorizing fish. It was business as usual. But there was a light in the sky that had been getting bigger, and that particular morning, it seemed much bigger than usual. It was no star. It was a giant asteroid, estimated to be between 15 and 80 kilometers wide. It was flying at speeds of over 30 kilometers a second and on a collision course with planet Earth. Its name was Chicxulub. If the same thing happened to us, we'd have only a few weeks between the time that we could see it by the naked eye and when it hit the ground. Suddenly, it hit the atmosphere, making it burn brighter than ever before. A few seconds later, it touched down. The asteroid crashed into a shallow sea,
in the modern-day Yucatan Peninsula in the Gulf of Mexico. The impact had the power of about 10 billion nuclear bombs, and everything within about 1,000 kilometers was instantly vaporized. In the rest of North America, the effects took a few seconds. First, a massive shockwave traveling at 1,000 kilometers an hour blew away trees and dinos. Then, the earth began to tremble. Magnitude 11 earthquakes shot dinos up into the air like a trampoline. A record number of T-Rex bones were broken simultaneously. The impact kicked up dirt into the atmosphere, which melted and rained down as burning glass and flying lava. The dinos beneath were pelted for close to an hour. The fireballs heated up the atmosphere to hundreds of degrees for a few minutes. The planet was a massive convection oven that cooked the dinosaurs evenly. The world was aflame as forest fires ravaged jungles and Cretaceous polar forests. Only those animals who could hide in burrows, caves, or underwater were able to survive. At the same time, earthquakes, tsunamis, and tornadoes devastated the land. The dust and soot lingered in the air for years, blocking out the sun and killing most of the surviving plants. The food chain was officially broken down. No terrestrial animal over 20 kilos survived this event. All non-avian dinos waved goodbye. In the ocean, the dark skies caused plankton to die, starting a chain reaction that would cause most large marine species to starve to extinction. Worldwide, only about a quarter of all species would survive. Some aquatic animals did survive the carnage going on at the surface. Sharks, turtles, and crocs were some of the ancient animals that survived. Small avian dinosaurs and tiny mammals also survived by hiding in burrows and caves. Those tiny mammals would eventually grow to rule the earth. They were our direct ancestors. This was one of the most important days in the history of the world, and we know how it happened thanks to paleontology. Let's start with the asteroid impact. We knew something dramatic happened at the end of the Cretaceous, because dinosaurs abruptly stopped showing up in the fossil record around 66 million years ago. Luis and Walter Alvarez, a cute father and son duo of physicists, observed that if you look at rocks from the end of the Cretaceous, eventually you find a band of clay with iridium concentrations 100% higher than normal. Iridium is very rare on Earth, but relatively common on asteroids. The rocks below the iridium-rich band of clay were chock full of fossils, but the ones above it showed barely any sign of having supported life. The evidence for an asteroid impact was there, and about a decade later, the crater was found in Mexico. It's not easy to realize you're in a crater, since it's 180 kilometers wide. Studies found abnormal quartz formations and tektites, the remains of the molten glass that pelted the dinosaurs, confirming the occurrence of the catastrophic event. It's possible that by the time the asteroid collided with Earth, other factors were already hitting dinosaurs pretty hard. There's evidence of climate change and elevated volcano activity in the Cretaceous, but the asteroid was the coup de grace. But the few terrestrial survivors persevered and eventually radiated into all the wonderful species we have today. And if you're feeling a bit down, remember this: your ancestors survived a massive asteroid impact and a catastrophic extinction event. You got this.
Understandings are first gained by seeing things at first hand, watching, experiencing.
Metamorphosis.
Metamorphosis, when one thing becomes another.
Metamorphosis.
When we talk about growth, we usually think of growing up.
Metamorphosis.
But the long road of growth is not just up.
This process is a truly mind-boggling phenomenon shared by over 65% of all animal species on Earth, the majority of which are insects.
Insects develop from young to adult in 3 different ways. They all start from eggs, of course. Silverfish illustrate the first method. The young are much like the adult except in size. There is no metamorphosis.
So many insects undergo metamorphosis that it would be easier to count those that don't than those that do. 2 common insects you may be unlucky enough to see regularly that don't metamorphosize are silverfish and bristletails. There are 2 broad categories of metamorphosis, complete and incomplete.
Incomplete metamorphosis, which means no basic change in structure from nymph to adult.
Hey everyone, we have exciting news! We're thrilled to announce the release of Animalogic's very first book, Strange Creatures. This book dives into the most incredible animals we've ever featured on the show, with each chapter packed with my illustrations and stunning full-color images. It's a fun and engaging way to learn about the animal kingdom, and a perfect tool to spark kids' interest in science. Each chapter breaks down an animal's biology, behavior, and all the coolest facts you need to know about these fascinating creatures. Animalogic's Strange Creatures is a must-have addition to your own library, or the perfect gift for an animal lover this upcoming holiday season.
Click the link in the description to check it out. And if you can, order a copy. It would mean the world. Thank you so much, and I hope that you love the book.
Incomplete metamorphosis is when an insect changes in several stages called instars or nymphs, depending on the species. These changes are often very gradual, and some species can have up to 15 nymphal stages. They start as eggs, then they hatch, and at the end of each stage they molt. During molting, the insect separates from their cuticle, their equivalent to skin. They begin to secrete materials that will form their new cuticle, while their old one eventually disintegrates and they break out of it. They're soft at first, but their new cuticle hardens up within a few hours. During this process, they gain new features. Cockroaches and crickets, for example, gain wings through molting, and their sexual organs only become functional after their final molt.
The young, called a nymph, has no wings. It gets wings in its final molt.
Because of this gradual development, adult insects that undergo incomplete metamorphosis tend to look like their babies, but with extra features, like a Pokemon's final form, except for maybe Magikarp. Complete metamorphosis is where things start to get really interesting.
Complete metamorphosis shows 4 distinct changes from egg to adult. The cycle starts when, for example, an adult Mexican bean beetle lays a cluster of eggs.
Species that undergo complete metamorphosis go through 4 distinct phases: egg, larva, pupa, and adult. Each one of these life stages serves a specific purpose. The goal of a larva is to eat as much as possible so that it can grow and develop, while the goal of an adult is to reproduce. In fact, in some species, the adults don't even eat. They spend their entire adult lives trying to reproduce, fueled by the energy stored by their larval stage.
Larvae hatch from the eggs. The larval stage is mainly a feeding stage.
Goliath beetles can live for up to 2 years in the larval stage and get particularly swole in preparation to pupate.
Now this one is 33 grams exactly now.
The adults generally lay their eggs near a food source so that when they hatch, the larvae can quickly begin to stuff themselves with as much food as they can eat. As they grow, they molt, and once they've developed enough, they pupate.
When all of the black widow's eggs have been eaten, the maggots pupate.
During this stage, they develop into their final form, adults. Some insects, like moths, form cocoons out of silk or poop to protect themselves as they go through this radical change. Butterflies, on the other hand, don't form protective cocoons, and instead their exterior forms a hard chrysalid. And like butterflies, they can be breathtaking. Some even look like gold.
The chrysalis is a resting stage, during which the animal changes into a beautiful butterfly.
During this stage, the larvae release enzymes that dissolve their own tissue. Once broken down, the adult structures begin to form out of tiny clusters of cells called imaginal discs. These imaginal discs are cells that are present when the larvae are born. They are attached to their epidermis by a thin stalk and remain dormant throughout their larval stage. Though once awoken during the pupal stage, they go to work. What they're able to do is almost too fantastical to be true. Once they're activated, the cells begin to divide very quickly to make more cells, eventually building entire structures like wings in just a few days. Even more fantastical is the fact that these elements are developed independently of one another and then attached later. So a wing may be grown in one area and then moved into place, somewhat like assembling a car. You don't have to build each part where it's going to end up. So a leg could be formed near the head and then moved down to its thorax. Even more fantastical is the fact that some butterflies can remember things from when they were caterpillars.
A caterpillar is a growing up stage in the life of a moth or butterfly.
A group of scientists did an experiment where they would emit a particular smell and then administer a small shock to a caterpillar. The caterpillar would learn to avoid the smell in the future. But the surprising thing is that after the caterpillars went through their metamorphosis, in which their bodies are completely dissolved and reformed, when presented with the same smell, the adult moths would freak out. This suggests that parts of their nervous system have continuity through their radical body change.
By the way, do you know how to tell a butterfly from a moth? Well, the best way is to look closely at the animal's antennae, or feelers.
Roughly 98% of all insects undergo metamorphosis, but it wasn't always this way. For millions of years, ametabolic animals, or animals that don't metamorphosize, reigned supreme. These early insects hatched as miniature versions of the adults, but that all started to change around 300 million years ago when a new player emerged. These new insects hatched with bodies that were radically different than their adult forms. Not only did they look different, but they behaved differently too. They ate different food and occupied different niches. Soon, they started to change their shape to best exploit the resources. For example, some newborns began to look more like worms in order to dig better and find meals underground, while the adults became larger and evolved tools for defense against predators, better vision for flying, color vision to find the tastiest food, and so on. Since insect generations are so short, new adaptations can evolve very quickly. Eggs began to hatch earlier and earlier. These pre-nymphs got better and better at fending for themselves and didn't need to stay in the egg as long. These became known as larvae. Though despite how adept these new larvae were at finding food and surviving outside the egg, they still lacked the sexual organs they needed to reproduce. Instead of a slow, gradual transformation, gaining sexual organs as they matured, these insects underwent brief periods of accelerated change, what we now know as pupation. With their various life stages able to dominate different niches, ametabolic insects, who could only specialize in one area and had to compete with their own young for survival, were pushed out of the market. Insects aren't alone. Amphibians and some fish also undergo metamorphosis. Frogs, salamanders, and all other amphibians can live on land, but they lay their eggs in the water.
The adult toad spends most of his life on land, but when spring comes, he returns to the pond for the mating season.
When the eggs hatch, the babies emerge with external gills and some fish-like features like fins and a lateral line, an organ that detects vibrations in the water and changes in water pressure. frogs and toads begin as tadpoles, and as they grow, their legs appear under their gill sacs and their mouths become larger. They start to transition from vegetarian to carnivore, and their intestines lose 75% of their length as a result. They lose their lateral line and instead develop binocular vision, which gives them depth perception. Their tails stay around a bit longer than the rest, but ultimately are lost. Depending on the species, this transition from legless vegetarian swimmers to hopping carnivorous amphibians can take between 2 and 8 months to complete. Some salamanders, like the axolotl, don't undergo a full metamorphosis and stay in their aquatic form instead, retaining their external gills throughout their lives. Amphibian metamorphosis is controlled by a single hormone called thyroxine, and we still really don't know how it works. This single hormone tells tail muscles to die, tells limbs to grow, tells intestines to shrink, and makes lateral lines completely disappear. All that from a single hormone.
I'd like to know more about different kinds of hormones.
Some species of fish also undergo metamorphosis controlled by thyroxine, though not nearly as many fish metamorphosize as insects, as their environment doesn't change all that much. That said, the fish that do change their strategies as they mature. Flatfish are born symmetrical and swim around like regular fish. But as they age, their eyes slowly start migrating to one side of their head so that they can eventually stop swimming and spend the rest of their lives on the ocean floor. Eels have 4 stages of metamorphosis, and their larvae are hands down the most mesmerizing larvae in the animal kingdom. In some species, they can stay at this stage for over 2 years, looking for nutrients as they grow and develop. Salmon undergo metamorphosis because they are anadromous.
They battle their way upstream against swift currents, seeking quiet waters where they may spawn.
Their lives begin in freshwater. Then they go out to sea, and finally they return to freshwater to spawn and die. They start out as alevins. During this stage, they survive off a yolk sac that is attached to them out of the egg. When they finish the yolk, they swim to the surface, fill their swim bladders with oxygen, and begin to look for food. In this stage, they're called fries. As the fries migrate to the ocean, they get larger, grow scales, and turn silver. They mature in the ocean before returning to the stream from whence they came. They stop eating and begin to make the struggle upstream. Once they've reached their destination, the males develop a hooked nose to fight each other for mating rights. After they spawn, they die. Metamorphosis is how most things on this planet get by, yet despite this, it's far too fantastical to describe it as common.
The astonishing change that takes place in this phase of the life cycle is known as metamorphosis.
A species' survival is entirely dependent on its ability to exploit and compete for the resources in their ecosystem. But sometimes those ecosystems change, and animals that have excelled with one strategy for thousands of years all of a sudden need to adapt. This can mean specializing in a new niche, broadening their niche to a more general diet, or pushing into an entirely different territory. Over time, this can lead to the creation of a new species. Amphibious mammals. Currently, several species of terrestrial mammals are dealing with ecosystem changes that have them turning to a life in the water.
Take this mother hippopotamus and her young son Sebastian, who is just learning to swim and is sticking close to mom.
Here in Canada on Vancouver Island live the sea wolves. These wolves are a population of grey wolf that are beginning to draw a genetic line in the sand, or beach. Unlike interior wolves, who primarily eat elk and deer, these coastal wolves eat seafood. Their diet is made primarily of salmon, but they also eat clams, seals, otters, and marine carrion. These elusive wolves roam the coast in packs of up to 20. They travel great distances in search of food, either by land or sea, and have been recorded swimming 12 kilometers in a single go. They are roughly 20% smaller than interior gray wolves, and DNA testing has found that they are actually genetically distinct from their mainland cousins. When hunting salmon, they hunt much like grizzly bears. They stand in the shallows where the salmon are spawning and catch them as they jump out of the water. These wolves were driven to the coasts and islands as their original territory was logged, leaving much less room for prey and predators to survive. Yet, while life on the coast isn't what gray wolves have excelled at historically, they have found some advantages. Hunting small prey like salmon is a lot safer than hunting their traditional diet of large ungulates, which could injure a wolf during the hunt. If interior wolves wanted to hunt salmon, they'd be competing with grizzly bears, who take to the islands in much smaller numbers, if at all.
Then one of the great epic struggles of nature begins. Day after day, week after week.
Grizzly bears are amphibious mammals, but they don't swim all that often. They primarily hang out in the shallows, waiting for salmon. Polar bears, on the other hand, are much more aquatic. Their habitat is made up of ice, and as that ice melts, they must take to the seas far more often. They have huge paws, designed for pushing their aerodynamic bodies through the water. They spend the majority of their time in the water traveling, preferring to ambush seals at seal holes rather than diving for them. Though, they will use the water as a means to approach unsuspecting prey stealthily. But they're not alone. Jaguars too use the water to silently approach their prey before striking. Living in such vast, diverse, and changing ecosystems, jaguars have become much more generalist in their diet than other big cats. They are fantastic swimmers and will dive into the water to hunt turtles, fish, capybaras, and caiman. In the Sundarbans, in the mangrove forests, tigers often take to the water to cross from island to island in search of prey. While tigers are less amphibious than jaguars, if their prey tries to escape them in the water, they will dive in pursuit. Though in the East, the cat that reigns supreme among amphibious mammals is the aptly named fishing cat. These rare felines are found in the Bay of Bengal, with most of them living in the mangrove forests and swamps of the Sundarbans. These cats are right at home in the water. They are excellent swimmers and hunt their aquatic prey either by fishing it out from the surface with their big paws or by diving in to get it. These bulky-looking cats might not look like amazing swimmers, but they have a few adaptations that give them an edge. Their paws are partially webbed. This helps propel them through the water as well as giving them more surface area to walk on when strolling through the muddy wetlands, stopping them from sinking in. They also have thick layers of fur perfectly adapted for life in the water. The bottom layer is short and dense. This keeps the fishing cat's skin dry and warm while swimming. The top layer is longer, and this is where they get their pattern. This is used for camouflage.
It looks like revenge, but the cat will be all right, a little wiser and cleaner.
Fishing cats took to the water for survival. There was far too much competition on land from similar predators, but now they face the opposite problem. As humans are pushing further and further into their territory, the wetlands are beginning to disappear, and the fishing cat will be left to either adapt or die. While the kingfisher might hold the title for the most graceful diver, perhaps the cutest diver is the ridiculously adorable water shrew. These shrews are the smallest warm-blooded diving species in the world. They're about the size of your thumb. They are primarily insectivorous and have found a lot of success hunting larvae in the water. They can dive for up to 45 seconds. Not the longest dive in the world, but it's long enough for them to catch their prey. When they dive, their fur fills up with bubbles, and when they stop swimming, the bubbles push the shrew straight up to the surface, like an adorable little life jacket. These bubbles also give the shrews a layer of insulation, reducing heat loss underwater by about 50%. This is especially helpful for the North American species, which dive in cold water for most of the year. Though, the North American species have another adaptation for staying warm during their cold dives. They can control their metabolic demands, creating more body heat on command. There are even some reports of water shrews that are able to walk on water.
You gotta get this, Eric. This is like pretty significant, man.
Their feet are covered in little fringes of hair that may help trap air bubbles like their fur, allowing them to not break surface tension. This could be helpful when escaping predators, or possibly when hunting prey as it emerges from the water. Unlike all the other animals we've talked about who have changed their behavior to take advantage of a new or different ecological niche, the swimming pigs of the Bahamas started swimming after the discovery of an entirely different niche: tourists. The pigs of Big Major K have discovered that if they're really cute, humans will feed them. And as it turns out, swimming pigs are in fact pretty damn cute. We're not entirely certain how the pigs got to the island in the first place. They may have been brought there by people hoping to settle. They may have swam to shore after a boat capsized, or they may have been brought as tourist traps. Whatever the reason, they are certainly making the best of it. There isn't a lot of food for them to eat on the island, so their diet relies entirely on what people bring them, hence the cuteness. But this isn't a habitat that they chose to push into. Instead, they're making do in a habitat where they're not meant to be. Recently, 10 pigs were found dead on the island. This was in part due to people giving them alcohol. But autopsies revealed that it was primarily from ingesting large quantities of sand. Tourists would throw their food on the beach, which the pigs would then swallow whole, sand and all. This small island leaves them little room to adapt. A couple of dry months can easily decimate their populations, forcing them to eat and drink things that they shouldn't. This is not the first time that mammals have sought new niches in the water. The ancestors of whales and dolphins turned to the sea for food and slowly transitioned from terrestrial to amphibian to fully aquatic. Will these more recent changes in behavior lead to a more permanent split? With the world changing as rapidly as it is, it's anyone's guess.
Show me your teeth, and I'll tell you who you are. Teeth are one of the most useful and specialized adaptations in the animal kingdom.
Not everyone has teeth which are snow white and evenly spaced, but anyone can have clean ones.
You can generally get a lot of information about an animal's diet just by looking at the tools in their mouth. In some cases, teeth can evolve into really strange tools.
How are your teeth? Have you thought of them lately? Well, that's what we want to talk about your teeth. Will everybody in the audience please run the tip of his tongue over his teeth? Just to get into the spirit of the story, please. That's right. Thank you.
Teeth had humble beginnings. They're thought to have originated from modified scales that helped the first jawed fish catch their prey. Since then, fish teeth have developed into a variety of weapons.
Most fish are carnivores, and so their teeth are designed for snatching prey. The ocean-dwelling Sloan viperfish and the vampire fish of the rivers of South America separately evolved giant needle-like teeth to kill prey. In the vampire fish's case, their teeth can be up to 15 centimeters long.
The vampire fish doesn't really drink blood, but there are fish that do, and their mouths are even more terrifying than your favorite Transylvanian ghouls.
The sea lamprey, for example, has concentric rows of teeth to attach itself to its prey. Then, it uses the teeth on its tongue to scrape off scales and flesh until its prey bleeds. It will stay attached until it's had its fill of blood. Similarly, cookie cutter sharks have circular mouths with teeth designed to gouge almost perfectly circular chunks of meat in one bite. They usually target larger prey that are unable to stop the small shark's swim-by attack.
Of course, if we're talking about sharks, we need to mention the incredible badassery of the helicoprion, which lived about 300 million years ago.
Their lower jaws have a spiral-like structure full of teeth called a whorl. How it's used and where it's located on the shark has been a mystery for a century, but new studies indicate that it sat inside the mouth closer to the jaw joint. Paleontologists say that the buzzsaw shape was probably used to snarl and slice into soft-bodied prey like squid. Their cousins, Carcharocles megalodon, were the largest sharks to ever live. They had relatively normal teeth, except for the fact that they could be over 18 centimeters long and serrated like steak knives. Their prey probably consisted mostly of whales, so big teeth were necessary.
Looking at the mouth of a predator, it becomes very evident that you don't want to catch the business end of those chompers. One of the most terrifying sets of teeth ever belonged to the mighty T-Rex.
To get into the juicy parts of large, thick-skinned dinosaurs such as the Triceratops, T-Rex needed some of the largest teeth ever recorded. They were about twice the size of a banana to go along with a bite that could produce 7 tons of force.
If you're watching this video looking for nightmare fuel, the best places to start are sheepshead fish and leatherback turtles. Trust me.
The sheepshead fishes and sizers are eerily human-like, and they also have rows of molar-looking teeth on the roof and bottom of their mouths. They use these chompers to grab, grind, and crush hard prey such as clams and oysters. The beautiful and famously chill leatherback turtles prefer softer prey such as jellies, but keeping them from slipping out of their mouth can be tricky. Luckily, they have terrifying teeth-like spines lining the inside of their mouths, all the way down to their esophagus. They point backwards, so jellies trying to sneak out get stuck in them.
They're like traffic spikes for lion's mane jellies.
If you are out of toothpaste, a mixture of baking soda and salt will clean your teeth very well.
Moving on to mammals, but staying in the ocean, we have the misnomered crab-eater seals.
These chunky dog mermaids don't eat crab at all. They're actually Antarctic krill specialists, and their teeth play a vital role in their hunting success. When they encounter krill, they take a big gulp and then push out all the water through the sieve-like teeth. The water goes out and the krill stays in.
Another marine mammal, the narwhal, has one of the most impressive canines in the animal kingdom.
Though it looks like a horn, the narwhal's tusk is an elongated canine tooth that can reach lengths of up to 3 meters. Nobody knows what they're used for, and theories range from sexual selection to hunting tools to communication devices. What we do know is that they're extremely sensitive sensory organs and might be able to detect changes in water pressure and ocean salinity.
On land, having a nice set of teeth is usually a great way to get mates.
Turned down by the girls. Can't get to first base. A failure in the army, in business, in romance. Reason? Bad teeth.
Walruses have gigantic tusks about 1 meter long. They use them to fight for access to females, but in most cases, just having larger teeth discourages potential challengers from picking a fight. Vampire deer, unlike most other deer species, lack large antlers, and instead, they have long, sharp fangs.
To fight, they stand on their hind legs and punch each other in the face until one falls down. Then the one that's left standing comes in with its sharp fangs to deliver a coup de grace.
Elephants sometimes also use their huge tusks for self-defense, but serious tusk fights are rare. They're mostly used as digging tools when looking for salt, water, and roots. They also use them to mark their territories by stripping the bark off trees.
The weirdest tusks belong to the babirusa. At first sight, they seem like obvious fighting tools, but they're far too brittle to be used in battle.
Babirusa are more boxers than fencers, and prefer a good slap over the face than stabbing each other with their tusks. Their real purpose remains a mystery, but they're probably a way to display fitness. Unfortunately, their fitness display can become too much of a good thing, as their tusks are known to curve backwards. If they get too long, they can pierce through the babirusa's eyes and skull.
Finally, we have the naked mole rat, an industrious little rodent that uses its teeth as boring machines.
Naked mole rats are burrowing animals and spend all of their lives underground. Their teeth are outside of their mouths, so they can dig without swallowing dirt. They're also used for fighting off invaders and predators. But the amazing thing about them is that they can be moved individually for more precise digging and to carefully carry their babies.
Sure enough, when her friend, the dentist, looked at Judy's mouth, he was pleased to see her healthy gums and teeth.
Is there a black sheep in your family? There are 4 in Elaine Knutson's. The 12-year-old 4-H girl from Petaluma, California, is raising quadruplet lambs, 2 boys and 2 girls, all black. All black.
Melanism is an adaptation that serves 2 purposes. It increases an animal's chance of survival, and it makes it look awesome.
Black is then added to give tonal value and depth to the colors. Color strongly influences our daily lives. It can appeal to us pleasantly.
Prey species, like melanistic eastern gray squirrels, become less conspicuous to predators, while predators, like the melanistic leopards, become more effective ambush hunters. Melanism occurs in hundreds of different species. For felines, the most popular melanistic species is the black panther, which are really melanistic leopards or jaguars, though melanism does occur in several other cat species, including the serval, domestic cat, and a few others.
Leopards are nocturnal animals, so being darker in these dark environments makes them almost impossible to spot.
Melanism occurs in about 11% of the leopard's range, but the vast majority of black panthers are found in the dense tropical rainforests of India and Southeast Asia. In some areas of the Malay Peninsula, almost all leopards are melanistic. In the exposed savanna, virtually all leopards are spotted.
The gene for melanism in leopards is dominant, so even if a panther mates with a spotted leopard, their babies are likely to be panthers.
Melanistic jaguars are more rare and only occur when both parents are melanistic. But if you're lucky enough to encounter one, it will probably be one of the most beautiful animals you'll ever see.
The melanistic form of the red fox is the silver fox. They used to be relatively common, but overhunting has reduced the proportion of the population that's melanistic.
Records from the Hudson's Bay Company show that up to 25% of the fox pelts traded in British Columbia from 1825 to 1850 were silver. Their pelts were more valuable than red pelts, which gave trappers an incentive to target them. Because of this, only about 5 to 10% of modern red foxes are silver.
In squirrels, melanism is rare, with only about 1 in every 10,000 squirrels being totally black. This is caused by a recessive gene, and only a pair of black squirrels can mate to make melanistic babies.
This is what you might call a squirrely story. Meet Miss Florence Hinton of Grover City, California, who has trained a small platoon of the bushy-tailed little rodents into amiability and a desire to please. Snookums here is a motherly little old lady squirrel with quite a talent for babysitting.
Their coloration seems to be an adaptation for life in dense forests, as a way to be less conspicuous to owls and other raptors. Despite this, there are some urban areas where they thrive. My hometown of Toronto, Canada, has one of the largest concentrations of black squirrels in the world. Several other rodent species, like marmots and mice, have similar melanistic fashion sense.
Melanism can be caused by human activity. This is known as industrial melanism and is one of the best examples that we've witnessed of natural selection in action.
Industrial pollution kills lichen in trees and creates a lot of soot that builds up everywhere. This makes lighter individuals stand out more against their background, and the darker individuals more likely to survive.
A particularly good example of this is the peppered moth.
At the beginning of the 19th century, there were no records of melanistic pepper moths.
They were all mostly light gray, but when the Industrial Revolution kicked in between 1820 and 1840, black peppered moths were reported.
Their numbers increased rapidly, and by the end of the 19th century, 98% of peppered moths were black. Then, as environmental regulations were enacted and soot deposits washed away, the lighter morph recovered. Today, over 70% of peppered moths are mottled light gray.
This girl's hair looks light when we see her between two dark-haired girls. But if her companions are light blondes, the girl in the center will now impress us as having dark hair.
Industrial melanism has occurred in over 70 species of Lepidoptera and a few beetles, but it's not the only reason some insects are melanistic.
There is a positive correlation between insect melanism and pathogen resistance. Insects that live in high-density populations, such as Spodoptera moths, need to develop stronger immune systems. One of the ways they do that is by beefing up their phenyloxidase system, which kills or neutralizes pathogens by bombarding them with melanin. As a side effect, a higher proportion of them are born melanistic. In birds, melanism is rare, but melanistic penguins, owls, and quails, among others, have been reported.
My two favorite melanistic birds by far are the black silky rooster and the Iam samani. Both of these domestic fowl are not only black on the outside, but also black on the inside.
See the eyes? The eyes is very black. Because in the tongue color is black, right? You have to make sure that everything is black. Thank you.
Their beaks, wattles, combs, tongues, bones, and even organs are all jet black. Their black coloration makes them much more attractive to breeders, and so their hyperpigmentation indirectly has led to higher chances of producing offspring. While Samanis are quite rare, black silkies are very popular and known for being super docile and are sometimes kept as pets.
And in case you're wondering, there are no known cases of melanistic humans, but there are lots of animals and humans with the opposite condition, albinism. But that's a conversation for another week.
The man is delirious. You don't actually believe he saw a white gorilla, do you?
When Meanie comes near, there is always trouble. She shakes her horns at any animal in her way.
The lives of herbivores are dangerous and full of stress. Predators on the prowl, battles for their role in society, and the constant search for food leaves them little time to relax.
Luckily, some of them have evolved tools to make their lives a bit easier. Headgear.
King could easily push his head through a fence or wall.
However, the buffalo in captivity have forgotten their wild ways and do not realize their strength.
Horns and antlers are super useful tools that started out as single-purpose structures and quickly became vital to the survival of their species.
Horns and antlers were originally weapons for males to fight other males with, and to this day continues to be their main usage. But it has expanded to be a sort of symbol of success and power for these males.
Ungulates are the kings of horns and antlers.
Almost every species of ungulate has some sort of fighting apparatus on their head. Most large species, like moose and water buffalo, have large headgear, while smaller species, such as vampire deer, tend to have tusks or fangs instead.
But how did they get so big? That's a question that we're still looking for definitive answers to.
Growing up is a strange and exciting experience, full of pleasure, pain, and wonder. During this period, size increases, but the body is out of proportion. Head large, legs small.
One of the theories is that as primitive mammals got bigger, they began to use their head as a weapon. Their head, of course, was also getting bigger, and their skulls started packing more of a punch. During combat, animals would stand side by side and hit each other on the head until one of them rolled over or gave up. Over time, thicker skulls and headgear developed as tools to win these fights, either by wrestling like deer or ramming like bighorn sheep.
At the same time, they became defensive weapons against predators.
Many thousands of years ago, our prehistoric ancestors were forced to protect themselves against the larger animals, even some of those that they later learned to use.
Lions had a new reason to worry about attacking a large buffalo, and they became display organs when females began favoring males with larger horns or antlers. Smaller ungulates tend to live in more dense forest, so it's more practical to have fangs than big headgear.
When fighting in close quarters in the dark, it's easier to use a knife than a baseball bat.
In more open environments, headgear now has two uses. One, to fight your enemies, and two, to win the fight before it even starts. In fights, usually the bigger guy with the bigger horns or antlers wins. But even in winning battles, there's a good chance of injuries.
The best case scenario is having headgear so big that it intimidates your rivals and prevents them from wanting to fight.
This creates open societies where hierarchies can be established with very little fighting.
But enough theory. Let's take a look at some of the coolest horns and antlers in the animal kingdom. First, the rammers.
The ibex has huge horns that can be up to 1 meter long. These mountain goats fight in perilous conditions where a bad step can lead to a lethal stumble. If you're an ibex in a fight, what you really want is for your rival to stumble down the mountain and never come back up. Its cousin, the markhor, aka the screwhorn, is also a mountain dweller, and its fights consist of getting the high ground and ramming its opponents down the hill. Males can weigh over 100 kilograms, and their horns can be up to 100 centimeters long. The North American bighorn sheep dwarfs the other rammers. Males, also known as rams, can weigh up to 230 kilograms, and their horns weigh as much as the rest of their bones combined. So it goes without saying, don't get into a headbutting match with a ram.
Moving on to the wrestlers, we have pretty much all the bovines and the ungulates with antlers.
Despite the stereotype, bulls don't chase after the color red or ram anything that moves. They actually prefer to grapple each other to the ground. The giant eland has huge and tightly spiraled horns, which can be up to 120 centimeters long. These African badasses have never been domesticated, as they're too strong and temperamental for people to handle.
If they can fight off a lion, they can probably fight off a cowboy.
Buffaloes are also a tasty but dangerous meal to predators. Though they're relatively docile, their horns are long and sharp and can easily gore predators to death.
Some species can weigh up to a ton, so this is not an animal that you want to wrestle.
Buffalo are not tame and do not make good pets. They cannot be trusted because you never know what they will do.
Among domestic breeds, the coolest one is the Ankole Watusi, whose horns are about 1 meter in circumference. They keep growing throughout their life and can get to over 2 meters long.
The two main differences between horns and antlers are that horns have a keratin sheath and antlers are made entirely out of bone, but also, horns are permanent and antlers shed every year.
Among the coolest antlers, we have the moose and the red deer. Moose have palm leaf-shaped antlers. In some subspecies, they can be up to 1.8 meters across. They help them show off their strength, fight predators and foes, and possibly work as a parabolic antenna to help them hear better. Each winter, they shed their antlers, as they're big, heavy, and radiate a lot of heat, so they're a major inconvenience. During the spring, they start growing again at an incredible 20 centimeters a week.
It's one of the fastest growing animal tissues on Earth.
Red deer have twig-like antlers. They're not as massive as mooses, at just over 1 meter long, but they get a special mention for growing at about 2.5 centimeters a day. So, they can grow their huge set in just over a month, just in time for the mating season.
Ungulates are not the only horned animals. Among reptiles, there's a number of predators with really impressive headgear.
Most desert horned vipers have horns, but not all of them. Even within one litter, some are born with horns and others with just a big brow. Nobody is sure why they have these structures, but they seem to be either for eye protection, as camouflage, or as tools to break the outline of their heads. Some chameleons, such as the Jackson chameleon and the four-horned chameleon, have horns, which are apparently used to defend territory. Just like ungulates, having big horns is a good sign that they're not to be messed with.
Finally, we have insects. Though there are many species with head protrusions, I want to focus on two of my favorite horn wrestlers.
Rough and tumble is right. It's every man for himself.
Some large beetles, such as the Atlas, Hercules, and rhino beetles, have horns as long as their whole body, and they use them to wrestle challengers off branches. These are some of the largest beetles in the world, and also the strongest fighters.
The rainbow scarab is one of the coolest looking beetles in the world.
They have an amazing iridescent metal sheen and a big ol' horn to fight each other. If they look a bit familiar, it's because we've talked about their family before. These are dung beetles, and when they usually fight for access to the freshest pile of poo.
Delightful!
Some shapes never go out of style. When it comes to evolution, the distinct squat figure of a crab has been in fashion for hundreds of millions of years. So effective is their form that even creatures that aren't technically crabs have evolved to be crab-like. Today, we're on location in Delaware Bay to witness the spawning of a total crab impersonator, the Atlantic horseshoe crab, Limulus polyphemus. Crabby body plans make so much evolutionary sense that even today's robots are being created in their image. This is the evolution of the crab.
Today, we're going to talk about some delightfully diversified decapods, crabs. These crustaceans have evolved not once, not twice, but 5 times into their classic rotund shape over the past 260 million years. Crabs are from the order of crustaceans called decapoda, which literally translates to 10-footed, and includes shrimp, lobsters, and crabs. The feet here not only refer to those that they use to scuttle, but also to their chelae, aka their claws or pincers, which are modified feet. Crabs have a long and diverse history. Currently, we have about 9,500 species of living crabs. From the fossil record, we know of about 3,300 extinct species. All in all, this is still just a small fraction of the total number of species of crabs that have ever existed. Fossil evidence of crabs first started appearing in the Jurassic period, but the diversity of these crustaceans really took off in the Cretaceous period, which began 145 million years ago. And the tendency to become like crabs has been booming ever since. A crab-like body has a few shared characteristics across species. First, the hard upper shell, called the carapace, is flattened and widened. Next, it has a broad sternum. Finally, it features a tail, called a pleon, that is folded under and lacks most of its musculature. If you've ever eaten lobster, shrimp, or crayfish, you'll know that the pleon is where the tail meat can be found. Crabs evolved from ancient decapods that had long pleons. One of the oldest decapods we've found is called Paleopalemon. This lobster-like crustacean lived around 365 million years ago during the late Devonian period. To trace their history, let's start at the beginning, when crabs truly came into style around 260 million years ago, when decapods split into 2 groups, the brachyurans, true crabs, and the anomurans, the false crabs. Brachyurans, which include spider crabs, fiddler crabs, mud crabs, and swimming crabs, take the prize for most successful decapod crustacean. These true crabs have conquered ecological niches, from freshwater streams to coral reefs, all the way up to dry land. The earliest of the brachyurans that we've found is called Eoprosopon klugi, and it lived during the lower Jurassic around 185 million years ago. Anomurans, which includes porcelain crabs, king crabs, hermit crabs, and squat lobsters, have evolved similar qualities but are not actually true crabs. An extinct example of an anomuran is Paralomus dubodiorum, which lived during the Middle to Late Miocene, which spans 16 million to 5.3 million years ago. This false crab, with its nubby carapace, was an ancient member of the king crab family called Lithotidae. The earliest anomuran that we know of is called Platycauda achaina. It lived during the late Triassic, around 250 to 200 million years ago. It is a false crab and looked a little bit more like a lobster than a crab. The easiest way to tell the difference between a brachyuran and an anomuran is to look at the number of walking legs. True crabs have 4 sets of walking legs, while false crabs appear to have only 3, because the 4th set is shrunken and sometimes even tucked up into their gill chambers. Anomurans also usually have longer antennae, which are positioned to the side of their eyes. Evolving to be more crab-like in appearance isn't just limited to decapods. This advantageous shape has been adapted by plenty of unrelated species too. Today, we're on location in Delaware Bay to witness the spawning of a total crab impersonator, the Atlantic horseshoe crab, Limulus polyphemus. Hello, Delaware. Oh no, we've got one who's flipped over. Gotta help him. crab in horseshoe crab is actually a complete misnomer, as they're chelicerates, making them more closely related to spiders and scorpions than to true crabs. The oldest horseshoe crab fossil that we've found is called Lunataspis aurora. Beautiful name, right? And it dates all the way back to the Devonian. This was a time before creatures evolved out of the water and onto land. And somehow, these creatures have hardly changed since. Ooh, we're getting to see an awesome example of a horseshoe crab trackway. These trackways are extremely distinct, mostly because of the shape of their final pair of limbs, called the pushers. Now, they have such a specific morphology that we can see these trackways in the fossil record and know exactly what kind of animal made them, which is part of why we have such a rich and deep history of the evolution of limulids. Can you tell I'm excited about these things? 'Cause I am. Even if you don't think that these creatures are as charming as I find them, you probably should still thank them. Chances are they've affected your life in more ways than one. All right, you can see the big mama right there. And latching onto her back, onto her shell, is a male. Horseshoe crabs, like this one beside me, are one of the many species that have undergone carcinization or brachyurization. This is the convergent evolution phenomenon that sees non-crab creatures turn into crab lookalikes. The reason that organisms turn into crab wannabes is still a bit of a mystery. One likely explanation is that it's all about mobility. That classic crabby shape just works for life in and around the water, allowing for things like greater protection from predators and easier movement and feeding. Even humans have taken a page from the crab style guide and have implemented their design into some of today's technological advances. Engineers at Northwestern University used the peaky toe crab as their inspiration for half-millimeter, remote-controlled robots that are able to bend, crawl, walk, turn, and jump. Though crab-like body plans have been all the rage over the past 260 million years, there have been documented cases of crustaceans that were more crab-like evolving to be less so over time. This process is called decarcinization, and it's happened over 7 times that we know of. In 2019, an extinct decarcinized species of crab from around 90 million years ago was discovered. Just the size of a quarter, its unique features include paddle-like legs, long body, and exposed tail, led it to be dubbed Chimera perplexa, or perplexing beautiful chimera. As we can see from hundreds of millions of years of evolution, the crab-like body plan is as practical as it is beautiful. Chimeras, also known as ghost sharks, are the forgotten members of the cartilaginous fish class Chondrichthyes. When people talk about these fish, they usually only talk about sharks, rays, and skates. And forgotten are these deep-sea Frankensteins. The majority of chimera live in the deep oceans around the world, thriving in depths beyond 200 meters. Some chimera have been found living at 2,600 meters deep, though there are a few species, like the fantastically named Chimera monstrosa, that live in much shallower waters, around 50 meters deep. The chimera's closest relatives are sharks, but they parted ways 400 million years ago, about 10 million years before our ancestors emerged from the water. And they haven't changed all that much since. Chimera are the most primitive known cartilaginous fish. While they still bear some resemblance to sharks, they can be easily told apart. One of their most prominent differences are their gills. Sharks can have up to 7 gill slits, while chimera only have 1. And their gill slit is covered by a flap called an operculum, like bony fish. Also like sharks, chimera don't have any bones in their body, and their skeleton is made of cartilage. Depending on the species, chimera can measure up to 1.5 meters long. While they are hard to study due to their deep-sea locale, they're estimated to live well over 20 years in the wild. To defend themselves, most chimera come equipped with a venomous dorsal spine. This spine is located on their backs. It's a modified scale and it breaks off after every use, after which the chimera grows a replacement. This dorsal spine is very useful in defense and is incredibly painful to humans. Chimera venom can cause necrosis, hallucinations, localized paralysis, and a lot more. You do not want to mess with these ghosts. Chimera reach sexual maturity fairly late in life, and like sharks, male chimeras have external reproductive organs called claspers. They use these tubes to insert sperm into the body of the female. If successful, the female will lay large, leathery eggs. Chimera have a particularly difficult time when targeted by fisheries or when caught as bycatch. Their bodies are so adapted to living at crushing depths that when they're hauled out, their bodies can't handle the change, and most don't survive the process. There are 3 families of chimera. The first contains the plow-nosed chimera, or elephant fish. They get their name from the fleshy appendage sticking out of their face. They can measure up to 125 centimeters long and use their plow to find bottom-dwelling prey, like sea urchins, mollusks, and crabs. Their plow is lined with electroreceptors, which help locate hidden prey by sensing their electric field. Every time a mussel moves, it creates an electric field. Even if their prey sits perfectly still, their hearts give them away. Then the chimera strikes, crushing their prey with their broad, flat teeth. While elephant fish may have the most specialized electroreceptors, all species of chimera have sensory organs used to detect electric fields to find prey. And the coolest thing? You can see them. If you look closely at this chimera's face, you'll see that it's lined with little dots. These are their electrosensory organs. Similar to frogfish, elephant fish have large pectoral fins that help them move along the ocean floor. The second family are the short-nosed chimera, or ratfish. Their snout is much shorter than their plow-nosed cousins, and they have a much longer and skinnier tail, hence their name. Finally, the long-nosed chimera. These fish have long, paddle-shaped noses, and all 8 living species are found in deep, open water. They're also known as spookfish, for obvious reasons. Also definitely reminds me of Zero from Nightmare Before Christmas. Anyone else getting that vibe? Lamprey are an order of about 40 species of ancient vertebrates called petromyzontiforms. 18 of those species are carnivorous, parasitic, and here to give you chupacabra vibes. Lamprey are sometimes inaccurately called lamprey eels because of their resemblance. While eels are elongated bony fish, lamprey skeletons are made out of cartilage, actually making them more similar to sharks than to eels. And even though they are slippery as eels, thanks to their lack of scales, eels, these vampire wannabes, are not. The Atlantic's taken to eliminate it, but since the lamprey has stayed roughly the same for the past 340 million years and survived 4 major extinction events, this slippery fish is certainly in it to win it. 2021 marks the 100th anniversary of the Atlantic sea lamprey invading the upper North American Great Lakes.
While Atlantic sea lamprey are native to Lake Ontario, the final lake in the chain of Great Lakes which serves as the outlet to the Atlantic Ocean via the St. Lawrence River, it wasn't until relatively recently that they gained access to the rest of the Great Lakes. Niagara Falls acted as a natural barrier, keeping the Atlantic sea lamprey from accessing Lakes Erie, Huron, Michigan, and Superior. It wasn't until 1921 that they were first spotted in Lake Erie, 2 years after the man-made Welland Canal, which bypasses Niagara Falls, was deepened.
By 1938, they were running loose in all the remaining Great Lakes, as well as many other connected bodies of water.
To feed, the Atlantic sea lamprey and other carnivorous species suction themselves onto their victims with their sharp, horn-like teeth that encircle their jawless mouths. Once attached, they use their pointed tongues to bore through the fish's scales and flesh, a process that is terrifyingly called rasping.
Once latched on, they suck the blood and other bodily fluids from their prey. Anticoagulant enzymes make sure that the helpless victim's blood doesn't clot and stop the suckfest.
Creatures that drink blood are known as hematophagous. This includes creepy crawly pests like mosquitoes, ticks, fleas, bedbugs, and leeches, which also use anticoagulants to keep their prey's blood flowing.
Ooh, oh, he's biting. I can feel his teeth digging into my elbow.
Other hematophagous animals include the vampire bat, the red-tailed oxpecker, and the vampire finch. Check out our vampire episode after this if you're in the market for extra chills.
In the larval stage of their lives, lamprey are known as amocetes and are, by contrast, harmless as lambs.
The 5-inch long amocetes bury into the beds of streams and filter feed on algae and other microorganisms. They'll stay this way for about 4 years, or even longer for non-carnivorous species. Then they turn into transformers.
No, really, that's what the juveniles are called. They just look like smaller versions of their adult selves at this point. By the following summer, carnivorous lamprey transformers become full-blown adults. And that's when the feeding frenzy begins.
Sea lampreys feed on all types of fish, including trout, salmon, whitefish, yellow perch, walleye, catfish, and sturgeon. In their OG ocean home, Atlantic sea lamprey do not typically kill the fish they feed on, thanks to coevolution. Without this coevolution in the Great Lakes, however, sea lampreys have a 40 to 60% kill rate.
Each of these bloodsuckers can kill up to 40 pounds of fish during their 12 to 18-month feeding period. Then the adults spawn and die shortly after, leaving the next generation to pick up the torch of decimation.
Controlling lamprey populations in the Great Lakes takes a serious team effort. The Great Lakes Fishery Commission, in cooperation with Fisheries and Oceans Canada, the U.S. Fish and Wildlife Service, and the U.S. Army Corps of Engineers, all work together to keep lamprey populations down. They do this in a few ways, by treating infected streams with lampricide, which kills the lamprey amocete while having little to no impact on other fish and wildlife, with barriers to block the paths of spawning adults, and by tricking their keen senses of smell with pheromones to attract and trap them.
This fish might seem like a horror movie monster, but it's worth repeating that not all lampreys are terrifying bloodsuckers with nightmare holes for mouths.
The non-carnivorous species, for example, don't feed at all. Instead, they live on the reserves they've stockpiled during their larval phase, spawning and dying within 6 to 10 months of their transformation into adults.
For millions of years in the Miocene, South America was a strange and dangerous place. It was a time when the continent was isolated and weird animals evolved to fill the ecological niches that dinosaurs used to occupy. The top predator placental mammals that rule today, like big cats and dogs, hadn't arrived yet. The land was dominated by carnivorous marsupials like the Thylacosmilus, crocodilian reptiles like the Purosaurus, one weird carnivorous armadillo, and, of course, predatory birds. But we're not talking about eagles, hawks, or condors.
This land was ruled by terrestrial birds, some of which were over 2 meters tall and had the biggest bird heads ever recorded.
It's hard not to get a big head when you're the largest terror bird, but Kelenken took it to the extreme.
Just for context, the shoebill stork has one of the biggest heads among living birds.
Their beak is about 25 centimeters long, with sharp edges and a pointy tip. You do not want to have any part of you caught in its jaws.
But the shoebill's beak, plus their entire body, which can be as tall as me, only adds up to about 7 kilos in weight.
The Kelenken's head alone was heavier than a whole shoebill. Their skull was 3 times longer than a shoebill's, and their total body weight was 40 times more than a shoebill, measuring roughly 250 kilograms.
Yes, these birds were as heavy as grizzly bears, except unlike bears, they hunted on 2 legs. So they were in many ways more similar to a theropod dinosaur like Velociraptor than to any living predator.
Kelenken was about 3 meters long from head to tail and roughly 2 meters tall.
A single peck could probably split your head open, but we're not entirely sure if that's how they got their food.
The most common theories are that they killed their prey by pecking it to death or by grabbing them and shaking to snap their neck.
It's also possible that Kelenken was a kleptoparasitic scavenger and mostly stole other predators' prey.
That means these birds not only terrorized delicious prey animals, but also other ferocious predators as well. Nobody was safe from terror birds. Their fossils have been found in formations in Patagonia alongside extinct rodents like guillaumes and sparacidonts, who are marsupial-like predators. They might have been both eaten by the Kelenken and caught prey that the bird would later steal. Ground sloth babies were another likely prey of the terror bird. Yep, that's the saddest sentence I've ever said.
Kelenken was far from the only terror bird. One species was so successful that it was one of the few predators to colonize North America during the Great American Interchange.
This was Titanus, a badass name for a badass predator who lived from about 5 to 2 million years ago. It was slightly shorter than Kelenken and much leaner. It weighed roughly 150 kilograms, about the same as a jaguar or a small black bear. But as we know from those modern animals, that's plenty of weight to be a fearsome predator.
So far, fossils of Titanus have only been found in Florida and Texas, and there's a huge geographical gap between them and their closest relatives in South America.
That means that there were likely other terror bird species that exploited the rainforest habitats of Central America. We just haven't found them yet.
That might be an interesting project if you're an emerging paleontologist. We just ask that if you find a new species, you name it Animalogico.
Terror birds emerged shortly after the extinction of their ancestors, the dinosaurs, around 62 million years ago, and were at the top of the food chain for almost 60 million years.
Siloteris, the youngest recorded species, lived until sometime between 80 and 6,000 years ago.
Humans entered South America about 14,000 years ago. So if you're of South American descent, there's a decent chance your ancestors went head-to-head with a terror bird. I don't envy them. These birds could kill you before you even knew they were there.
Terror birds were not only huge, they were also fast. Some species, such as Mesembryornis milnedwardzi and Patagornis marshai, could run upwards of 70 kilometers per hour. That's as fast as an ostrich.
The difference is that ostriches evolved to run away from cheetahs, lions, and wild dogs, whereas terror birds could have hunted those big animals themselves.
CT scans of terror bird skulls show that they were not likely to be huge biters.
Their musculature wasn't meant to crush bone the way hyenas and crocodiles' jaws do.
To take on larger prey, they probably used a combination of kicking, pecking, and possibly grabbing their prey with their massive beak and slamming it onto the ground.
This is similar to how modern predatory birds, like secretary birds and roadrunners, kill their prey. Their feet were equipped with large claws that could tear open flesh, and were longer than the famously lethal cassowary's claws. Though even without the claws, the sheer force of their kicks would have been enough to at least stun their prey.
After that, depending on the prey, they would swallow it whole or shred it apart and eat the best pieces.
Unfortunately, the changes in climate and the arrival of placental mammals like wolves and big cats were the doom of terror birds. Every empire crumbles eventually, and in this case, it was these furry animals that came to take the crown.
But there's still a living relative of terror birds hiding in South America, biding its time, waiting for the right chance to make a power move. We have secured some footage, but viewer discretion is advised. This is the closest living relative of the Kalinkin, the Seriema. Okay, they're not as terrifying as their extinct cousins, but they do exhibit a lot of behaviors that are associated with terror birds.
I'd love to talk more about them, but they deserve their own episode.
We're still finding amazing fossils in South America. There are over 20 known species of terror birds and plenty more to be discovered. Stay tuned as we keep learning from these amazing beasts, although let's hope they don't come back to reclaim their crown.
Bobbit worms are some of the most amazing, beautiful, and deadly bristleworms in the world. These danger noodles have been around for ages. The oldest bobbit worm dates back to 400 million years ago, and it was found in the Middle Devonian rocks of Ontario. Described in 2017, Websteroprion armstrongi was a jawsome beast that was about 1 meter long. These worms are ambush hunters, and from a distance, they look harmless. But if viable prey swims within range, the bobbit explodes out of its hole and catches it in the blink of an eye. Then the prey is dragged down into the depths of hell and never heard from again. The origin of their nickname might be an urban myth, but their mandible's cutting power is true. They're known to cut small fish in half and stun larger prey just long enough to pull them into their mucus-lined burrows. Bobbit worms are mostly nocturnal predators, so they need to be able to sense prey in the dead of night without using their eyes. To do that, they have 5 antennae coated with sensory organs that can detect chemicals and vibrations in the water. Once prey is detected, it's time to go on a chopping spree. When striking, a bobbit worm fires out of its hole at around 6 meters a second. Their mouth parts are hidden, but on their way up to their prey, they turn outwards like a finger in a glove. The mandible provides the cutting power, and the secondary serrated mouth parts, called maxillae, grasp the prey and bring it into the mouth. There are some claims that the mandible can inject a paralyzing toxin, but this hasn't been confirmed and research is ongoing. But their head is not the only interesting thing about bobbits. Their bodies can be beautifully iridescent, and they're super long. Bobbits are just about 2.5 centimeters wide, but they can be up to 3 meters long. Their bodies are segmented, and each segment has bristles. As they grow, they add segments to their body. The current record holder for most segments was a Japanese bobbit with an amazing 673. Having all those segments can be helpful for 2 reasons. 1, they can be ejected in case they get caught by a predator, and 2, detached segments might still work as sexual organs. Bobbit worms have been observed breaking themselves into 2 or more parts when handled. Amazingly, sometimes more than one part can survive and regrow the missing parts. So, by splitting themselves, you get two short, genetically identical bobbit worms instead of a single long individual. The sexual aspect of their segment detachment hasn't been confirmed. Nobody knows quite how bobbit worms mate, but their closest relatives are all broadcast spawners. That means that the females eject unfertilized eggs and the males fertilize them. On some bristleworm species, possibly including the bobbit worm, as the animal becomes sexually mature, it grows gonads in its lower segments. When it's time to spawn, the lower segments separate and float towards the surface to meet other lower segments. It's like a blind date for severed genitals. If you find this cornucopia of adaptations a bit too much, you don't have to worry about encountering these long boys. Most bobbits live on the ocean floor at depths of between 10 and 40 meters, so you're unlikely to meet one of them at the beach. But if you have a saltwater aquarium, you might accidentally bring a bobbit worm into your house. Bobbit worms sometimes hitch rides in ocean rocks or water used to fill saltwater aquaria. When they're young, they can survive eating coral or other organic matter. But when they get big, they start going for the fish. Something like this happened at the New Quay Blue Reef Aquarium in England. The aquarium staff started finding mutilated, dead fish in the morning. So they set traps overnight, but they would come back to find that these traps were destroyed.
See those legs? It's like a horror movie. I don't know how to see this guy without pissing him off.
This led to a complete draining of the aquarium. After doing that, they found a 1.2 meter long bobbit worm, which they named Barry.
Oh my god, dude, I'm freaking out. That's some Tremor shit. Anybody see that movie?
By then, he had killed several fish, but was the most popular animal in the aquarium. So he was moved to his own enclosure and lived peacefully ever after.
And this is our famous bobbit worm underwater sand waterfall amazing tank. The bobbit worm is over here. This is a very deep sand bed, and he never seems to go below 2 inches of the sand, but we gave it to him anyway. I think he likes the waterfall. The view is too nice up top.
Atropa belladonna is a cute Eurasian cherry-producing plant with a terrible reputation.
Just to give you an idea, in addition to its common name, the deadly nightshade, it's also been called the death cherry, the devil's berry, and the beautiful death.
And to be fair, it's fully deserved. This plant is insanely toxic.
It contains tropane alkaloids to defend itself from insects that try to eat it. But in vertebrates, those alkaloids affect the smooth muscles of the body, including the urinary and GI tracts and sweat glands.
In some cases, it can cause extreme dry mouth, hallucinations, delirium, and even death. And of course, people have weaponized it.
In the year 1030, Macbeth and Duncan I of Scotland used deadly nightshade tea to poison the invading English troops of Harold Harefoot, killing many of them and forcing the rest to retreat. Emperor Augustus of Rome is rumored to have been poisoned by his wife Livia using this plant. She wanted to make sure her kid inherited the throne. Spicy.
This plant is native to Eurasia, but it's spread to Africa and North America, so there's a good chance there's a few near you. Here's how to identify it so you can steer clear of it.
They're a little over 1 meter tall, with small bell-shaped flowers and long leaves, which can be about 15 centimeters long. The berries are small and circular, and both the berries and the flowers start off green, but as they mature and become more toxic, they turn purple.
I'm serious. Stay away from this plant. Just 2 berries are enough to kill a child.
The roots are the most toxic part of the deadly nightshade, but a single leaf has enough poisonous alkaloids to kill an adult. The berries are slightly sweet, but if you eat more than a handful, you're in trouble.
Some animals, like rabbits, sheep, and cows, seem to be resistant to its effects. Bees readily consume its nectar and sometimes end up making slightly toxic honey.
Dogs, unfortunately, are not that lucky. So make sure to keep your pooch away from these killer plants.
But of course, industrious people have learned to use it in small doses for reasons other than regicide. In the Mediterranean, for example, it's been used as a cosmetic.
The scientific name, belladonna, means beautiful woman. Up until the Middle Ages, some women would make a sort of diluted tea and use it as eye drops. The alkaloids would affect the normal functioning of the smooth muscles of the eye and would cause pupils to dilate, giving them a unique look. Cleopatra apparently used it regularly, though the product was known to cause long-term damage to vision.
People were really into dilated pupils in those days. Deadly nightshade and some of its toxic relatives have been proposed as medicine for a number of health issues, although there's very little evidence that they work at all.
Chronic pain, irritable bowel syndrome, asthma, and hemorrhoids are just some of the ailments it's been used to treat. Unfortunately, as far as we know, most of the positive effects have most likely been cases of the placebo effect.
But with the right dosage, it's been shown to improve mood, libido, and cause hallucinations. So, in other words, it's been used recreationally.
In the Middle Ages, the church used to carry out witch hunts, which often targeted drug addicts. Deadly nightshade was a relatively common ingredient of witches' brew and caused its users to behave strangely, to hallucinate, and give them the feeling of being able to fly.
Of course, there were other compounds in their brews.
Medieval surgeons used it too, as an anesthetic, but it often caused patients to behave erratically and have vivid dreams. As religious persecution ramped up, its use was discontinued, as surgeons were afraid of being labeled as sorcerers.
So that's the story of a plant that started out by making compounds to fight off bugs and ended up as a favorite of kings, queens, and witches. You might be curious to see this one out in the wild, but just make sure you don't touch it.
They're so tasty. A healthy mountain treat.
6 hours later, we're both like...
Probably just like from both ends. I mean, I hope they're blackberries. We're gonna find out. Because I just ate like 2 handfuls.
Marabou storks are a large wading bird species in the stork family. The name marabou comes from an Arabic word that roughly translates to quiet or hermit-like. That might have something to do with the fact that the marabou stork does not have a voice box, so it can't sing like many other birds. However, they can make sounds by clapping their bills together or croaking through their throat pouch. Marabou storks are native to Africa and can be found in the wilds of Senegal, Eritrea, Ethiopia, Somalia, Namibia, South Africa, and Uganda, where it reigns as the unofficial national bird. They're comfortable in wetlands, semi-arid savannas, and grasslands. And because they're not too shy around humans, you can also find them in fishing villages or garbage dumps. The marabou storks have been very rudely called the ugliest animal on the planet, to which I say, beauty is in the eye of the beholder. The stork has been nicknamed the Undertaker bird because when seen from behind, its back and wings look like a long black cloak. It's also massive, which adds to the Grim Reaper effect. They're about 5 feet tall, weigh 20 pounds, and boast a wingspan that can stretch 3 meters. That is the largest wingspan after the albatross and the great white pelican. It has a large bill, a sunburnt-looking bald pink head, a white ruff, and soft white tail feathers, known as marabou. Marabou was actually an extremely popular feather trim in women's fashion. Even Marilyn Monroe wore them. The marabou stork's legs are skinny and white, and the white comes from, its own poop. That's right, it poops on its legs to cool down in the sun and protect itself from sunburns. I wonder if Marilyn knew where her feathers had been. Their leg bones and toe bones are hollow, which helps them balance their weight and take off to fly. I guess we should also mention that puffy reddish thing on the stork's neck. It's an inflatable gular sac used in courtship rituals. It's also the pouch it can croak from.
But let's move on from the marabou stork's unique physical appeal and focus on its personality.
While they may look like creepy goth loners, the storks are actually pretty social. They're often seen in groups and gather close together to roost at night. Marabou storks have a reputation for being lazy, standing around, sitting in trees, doing a whole lot of nothing. But this way of life helps them avoid expending energy unnecessarily.
So the next time someone calls you lazy and tries to get you off the couch, tell them you're doing very important marabou stork research.
Like other storks, it flies with its legs flowing out from behind its body. When in flight, it tucks its neck to form a flattened S, which helps the weight of its beak to rest on its shoulders. The marabou stork soars high up in the sky in the search for food. It's mainly a scavenger with an appetite for carrion. Like vultures, the storks will appear anytime an animal is killed, in the hopes of snagging a scrap. But it will eat almost any animal, dead or alive. Fish, frogs, lizards, insects, snakes, rats, flamingos, crocodile eggs, even young crocodiles.
They're also drawn to grass fires. The storks will fly ahead of the flames and swoop down to pick up small animals running away from the blaze. Oh my gosh, can these birds get any scarier? How about if we add killer bees?
Just kidding. They're regular everyday bees, and they follow the stork around in the hopes that the stork will pull apart the dead carcasses of animals, and the bee can eat what's left over and use the remains as shelter to lay their eggs. It's an animal relationship called commensalism, and it's really only beneficial for the bees. But marabou storks don't seem to mind.
Storks breed in the dry season when water levels are low. That means fish and birds are easier to find and catch.
During breeding season, they'll gather in groups ranging anywhere from 20 pairs to several thousand.
A male stakes out his territory and inflates his throat pouch when newcomers arrive. When females enter his territory, they pair up and nest building begins.
Couples tend to mate for life and construct their nests in trees, on the tops of buildings, and on the sides of cliffs. 2 to 3 eggs are laid, and after a month of mom and dad taking turns to incubate the eggs, they hatch. When they're born, the marabou is covered in a gray down. They won't reach full maturity until about 4 years old. Young marabou are browner with smaller beaks.
As they get older, they'll reach their Freddy Krueger phase, and many will eventually get age spots.
Marabou storks live about 25 years in the wild and 40 years in captivity.
Don't worry about their numbers. They're classified as a species of least concern, which means that they're gonna stick around forever, waiting, watching, for death, for fire, for food. Sleep tight.
Most insects have natural enemies, parasites and predators. The larvae of a tiny wasp has destroyed the internal organs of this aphid.
Parasitic zombification. This horror of evolution is exhibited by multiple species separated by thousands of years on the evolutionary tree.
The larvae of such parasites grow up inside the bodies of their hosts and emerge to pupate and start a new life cycle.
From fungi that turns ants suicidal, to chest-bursting wasps, to worms that feast on the insides of crickets, science fiction really takes its cues from nature.
The wave of murder is being committed by creatures who feast upon the flesh of their victims. First eyewitness accounts of this grisly development came from people who were understandably frightened and almost incoherent.
Parasite-host relationships are in an ongoing battle of evolution. The two are continually adapting to try to find advantage over each other. None are more fascinating than the behavior-altering parasites, the parasites that turn their hosts into husks of their former selves, with all free will removed. Zombies.
Zombies, the living dead.
Ophiocordyceps are a genus of fungi found primarily in tropical rainforests. Like many fungi, they need to spread their spores through the air to reproduce. But when living in a relatively windless rainforest, this can be difficult. But the Ophiocordyceps have found a solution. A fascinating and horrifying solution. Ants.
Ants are mostly a nuisance. New poisons are developed to rid us of insect pests.
The cordyceps will release a burst of spores as an ant passes by. If one of these spores lands on the ant, it can penetrate the ant's exoskeleton.
The skeleton of an insect is outside its body and is called an exoskeleton.
Once inside, the fungus grows rapidly, feasting on the ant's internal organs, and within 3.5 weeks, half of the ant's body weight is the fungus. The cordyceps severs the ant's nerves, cutting communication between its brain and muscles. It's now controlled entirely by the cordyceps. Yet despite this internal carnage, the ant still shows no symptoms. When the cordyceps have fully grown, it will guide the ant out of the colony, always when the sun is highest in the sky at noon, and lead it up a leaf that is 25 centimeters off the ground. The cordyceps are always sure to guide the ant to a leaf that is in their temperature sweet spot, between 20 and 30 degrees Celsius, and a humidity of 95%. This is the ideal temperature for the cordyceps to thrive. The leaf will also be close to an ant trail, making it easier for its spores to find a new host. Then, the cordyceps will have the ant bite the underside of the leaf, holding it in a death grip that the ant is unable to open.
Now, with the hook in deep, he twists it to make sure the victim will never get away.
Now, the cordyceps finishes the job. It devours the ant's brain, and over the next 3 weeks, it bursts out of the ant's head, forming a tall stalk. When grown, the stalk will begin to release spores along the nearby ant trail, claiming fresh victims. These parasites can devastate ant colonies, but ants have adapted. When they find a fallen ant, they carry its body far away from the colony in case it's been taken over by cordyceps. This is why it's so crucial for the fungus to force their host to look as normal as possible and thus skirt detection.
All law enforcement agencies and the military have been organized to search out and destroy the marauding ghouls.
This battle between ant and fungus has been happening for at least 48 million years. Scientists have found leaves of that age that have the trademark dumbbell-shaped death bite of the zombie ant. Yet despite their sinister reproductive strategy, cordyceps also find themselves victim to parasites.
And parasites that attack harmful insects are also helpful to man.
These parasites within a parasite are called hyperparasites. The one that the cordyceps are host to remains unknown. But they make it so that only 6.5% of all cordyceps can produce spores. Without these hyperparasites, ants would be in for a world of hurt. Cordyceps do target other species, but ants are the most effective due to their eusocial nature. Some ants find themselves victim to another type of parasite, the lancet liver fluke. These flatworms have a much more complex life cycle than cordyceps and begin their journey in the humblest of places, sheep poo. And what loves eating sheep poo? As it turns out, snails do. The fluke enters the snail, which shortly after releases it in little slime balls, an often favorite treat of some ants. Once eaten by the ant, the fluke will travel up to its cerebral ganglia. There, it releases a chemical that forces the ant to leave the colony at night, climb up a blade of grass, and wait to get eaten by a sheep. If the ant is so unlucky as to not be eaten, the fluke will have it return to the colony and pretend to be normal for another day, until it forces it to go out again. When it's eaten, the fluke will work its way into the sheep's liver, where it will lay its eggs to be excreted by the sheep, starting the whole process again. Other flukes follow similar life cycles, but instead of controlling ants to reproduce in sheep, they control fish to reproduce in birds. They infest the fish and then force it to constantly jump out of the water, making it an appealing snack to a passing gull. Lesson learned, don't trust a meal that looks like it wants to be eaten. Fortunately, the parasites found in water get a whole lot worse than flukes. The larvae of the aptly named kamikaze horsehair worm is born in water, where it is unknowingly gobbled up by other larval insects, like mosquito larvae.
The mouth parts are seen to be in constant motion when feeding at the water surface. Suddenly, the skin bursts along the middle of the back, literally oozing out of the pupil envelope.
When the infested mosquitoes eventually exit the water, they'll be eaten by crickets. Here, the horsehair worm will grow, sustaining itself by eating the cricket's insides. When it's fully grown and ready to mate, the worm begins to control the cricket's movements, forcing them to jump into the water and kill themselves. Multiple larvae can infest a cricket, leading to dozens of horsehair worms bursting from a single cricket. Once in the water, the horsehair worms will find a mate, reproduce, and restart the cycle. Green crabs fall victim to a similarly grim fate. The horrifically named castrator barnacle will make its way through a crab's joint into its exoskeleton. The barnacle will find its way to the rear of the crab, where their eggs are incubated and emerge from the crab as a sac. From this point on, the barnacle begins to change everything inside the crab's body. If the crab is female, it destroys its reproductive organs, and if it's a male, the barnacle starts to change the shape of the male to resemble a female. These body snatchers force the crabs to care for and lay their eggs as if they were their own. These parasites stay with the crab and use it to reproduce and guard its young until the crab dies.
This hornworm, covered with small silk cocoons, is doomed to die. A parasitic wasp laid its eggs within the hornworm's body.
Dinocampus coconelli wasps employ a similar strategy. They hunt ladybugs, and when they find one, they inject their egg into it. After 20 days, the egg emerges from the ladybug and forms a cocoon between the ladybug's legs. Zombified by a virus transmitted by the egg, the ladybug will defend the cocoon at all costs, which drastically increases its survival rate. Fortunately, this story has a happy ending. Well, more so than the others. About 25% of ladybugs recover from the zombification after the wasp has left the cocoon. But king of zombies, the ladybug killer is not. That title goes to the emerald jewel wasp. These wasps zombify cockroaches, usually about twice their size. When they find one, they sting it 2 times. The first sting temporarily paralyzes them. This second sting is much more precise. They surgically target the part of the cockroach's brain that controls dopamine output, stopping it, and taking away all free will of movement from the cockroach.
Cockroach spreads disease as well as ruining food. This is an enemy of man.
The wasp will eat one of the roach's antennae and use the other like a leash to walk the cockroach to its grave. Once in the hole, the wasp will lay her egg on the roach and block the entrance on her way out to protect her egg from predators. 3 days later, the egg will hatch and the larvae will burrow into the still living, still zombified cockroach. The larvae will feast on the insides of the cockroach before forming a cocoon. There, it will stay in the now dead roach until it finishes its metamorphosis, at which point it will burst out of the cockroach.
Black widows are a type of spider perhaps best known for, well, you know, sexual cannibalism. That memorable behavior is where the black widow got its name. But you might be surprised to learn that the rumors of their treachery are greatly exaggerated. There are over 30 species of black widow, ScarJo notwithstanding, but only a few of those choose to make their lovers a post-coital snack. So let's not stereotype these venomous vixens.
Some black widows sport the iconic all-black body and the red hourglass-shaped markings on their abdomen. But most species actually come in a wide variety of colors, from brown to red to completely black. Their life expectancy also depends on their species. Females generally live a lot longer and are much, much larger than the males. Black widows have been around for about 100 million years and can be found all over the world. They like warm, dry climates and prefer to spin their webs in dark, sheltered spots close to the ground. They feed on flies, mosquitoes, beetles, caterpillars, worms, grasshoppers, and hydra. You know, typical spider food. When the black widow catches their prey, they wrap more silk around them and paralyze them with venom.
Their venom is 15 times more toxic than a rattlesnake's. Not exactly a peaceful death.
Black widows use their sense of smell for a lot of the same things we do: avoiding predators, tracking down food, and finding shelter. But chemoreception is far more important for them. It's actually their main means of communication. The chemicals used to communicate are called pheromones. Most people associate the word with scents that make you attractive, but in the animal kingdom, they play a much larger role.
Pheromones have been used since some of the very first animals, and possibly by other life forms before them.
When it's time to mate, the female black widow releases pheromone-laced silk onto her web.
Those pheromones evaporate into the air and float far and wide, acting as a siren song to attract potential mates. Come to my web! You cannot resist me! Ah-ha-ha-ha! Thank you. That is my impression of Lolth, Queen of Spiders.
The pheromone signal becomes strong thanks to a process called sender-receiver coevolution. The females who send the most attractive chemicals are the most likely to pass their genes on to the next generation.
Enter the male widow. Like the females, this little guy's inherited quite the impressive genes from his 4 spiders. The ability to detect female pheromones in an ocean of chemicals.
It's thanks to evolution that these two have mastered the science of sexual communication. It's time for this male to show off just how good he is at picking up on sexy signals. If he's actively searching for a mate, he'll crawl up to a high place and wave his arms around a bunch.
And then he'll smell them to see if he's caught any pheromones. Very subtle stuff.
When he gets a hit, this spider heads straight to his potential partner, like a moth to a flame, or, you know, like a male spider to a black widow's web.
Some of you may be thinking, oh no, this poor little Spider-Man, he has no clue he's about to become brunch.
But remember, only a few species are sexual cannibals. And for those femme fatales famous for feeding on males, well, it's only if they're in the mood for a snack. If the male is smart, he'll mate with her after she's eaten.
How does he know if she's full? Chemoreception. If his sense of smell tells him that she's starving, he instinctively knows not to get any closer.
The female's web is covered in pheromonal discharge. Now, we get to see how those pheromones work via direct contact. When the male touches the web, he's sort of tasting the female's pheromones and gets kicked into romance mode.
The chemicals trigger his courting behavior. This doesn't mean wine, roses, and back rubs. Nope. Black widows opt for vibrations.
The female black widow doesn't even care that her mate seems weak and tiny. She's more concerned about his moves. And although her pheromones may have communicated she was looking for a mate, she may not be entirely sold on this male. Get off! Then his plan hits a snag. Another, bigger male, who's also been attracted by the female's pheromones, wants to shoot his shot. And he's not wasting any time. He immediately mounts the female black widow. And it's on! The two spiders battle it out for the female's attention. Who will win? Even though the smaller male put in all the hard work to court the female, the new guy has the edge because of his size. Please, take it somewhere else, boys. As usual, the bigger male wins out. Now to enjoy his success. He tries his luck at inserting his two palps, the sexual organs around his fangs that look like black balls, into the female's epiginum, the genital opening on her abdomen. Success! As soon as the palp goes inside the female, it curls up like a spring, and then he gives her his sperm. Aw, how sweet. Mating can last up to 20 minutes. Right about now, those hypnotic pheromones start to wear off. Will the male end up in the mouth of his mate? Or is this his lucky day? Whew! He walks away unscathed. He managed to survive a tango with the iconic Black Widow. What a badge of honor! Once the male leaves, the female can now lay her eggs in a gorgeous silky egg sac. These sacs can hold up to 300 eggs, and the sperm her male partner gave her can produce up to 10 viable egg sacs, which means this one tryst could result in 3,000 new baby spiders. Bye-bye bikinis. All in all, a highly productive day for black widows. Well done, you two. A credit to your species.
The erect, 3-centimeter wide green stems of the carrion plant make it the perfect cactus dupe. But this Stinky Stanley is actually a succulent, which are defined by thick and fleshy tissue that is specialized for storing water. Cacti are a subgroup of succulents, so while all cacti are succulents, not all succulents are cacti.
In the case of the carrion plant, this succulent is actually a member of Apocynaceae, the same family as milkweed.
Other less cadaverous names for the carrion plant include giant toad flower, Zulu giant, and starfish flower. But if you want to find out how this succulent ended up with a name like carrion plant, just follow your nose.
Carrion plant flowers emit a rotting flesh stench that is unmistakably stomach-churning and definitely deserving of the moniker.
This clustering succulent forms clumps that can sometimes reach 1 to 2 meters across. It's the most widely north-south distributed of the roundabout 29 species of Stapelia and can be found all over southern Africa.
Thanks to its unique characteristics, it can also be found as an ornamental on the shelves of the world's bravest and possibly most nose-blind succulent collectors.
Jokes aside, there's a good reason for all the stink. The scent attracts all manner of death-loving carrion flies who are fooled into fertilizing the plant. Pollination by carrion flies even has a specific name, sapromyophyly. Rafflesia and the corpse flower, which we've already covered on our channel, are two other examples of plants that use this sneaky scent scam for pollination purposes.
Unlike in the human world, there are certain advantages for plants that have major BO.
Carrion flies, for example, are present year-round, so they can pollinate year-round as well. In the case of the carrion plant, their blooms unleash their stink onto the world and are ready for pollination in the fall, when shorter daylight hours trigger the blossoms to open. But why do flowers produce scent at all?
Flowers are basically multi-sensory billboards for passing pollinators.
The objective for the plant is to get the pollinators, which could be bees, flies, wasps, ants, butterflies, moths, or even hummingbirds and bats, to touch their reproductive structures. The pollinator, in turn, gets a yummy snack out of the deal in the form of pollen, nectar, or oils.
It's a real you scratch my statement, I'll scratch yours situation.
But in the case of carrion plants, this relationship between fly and flower is actually one-sided, because the fly gets no reward whatsoever for paying a visit.
Instead of offering a sweet snack, the carrion plant is an expert at what's called brood site mimicry. The flies see and smell the flower, and thinking they found a heap of rotting, stinking flesh, they oviposit. or in layflies terms, they lay their eggs.
In the process of ovipositing, the flies will inadvertently touch the reproductive parts of the carrion plant, which is just what the carrion plant was hoping for. And this one-sided relationship only gets more toxic after the flies have left their eggs behind.
Unlike actual rotting meat, the flower lacks the protein that the larvae need to survive, so they will inevitably die.
One study even suggested investigating the carrion plant as a potential tool in fly control for this very reason.
The carrion plant takes being a multisensory advertisement to the extreme, with not only its pungent perfume, but also its looks. It looks like a large, fleshy starfish baking in the sun. And it kind of smells like one too.
Its flower is one of the largest in the world, with these star-shaped blooms reaching up to 40 centimeters wide. They can vary in color from cream to pale yellow and are covered in red or pink zebra stripes and fringes of hair.
Everything about the size, shape, color, and scent of this plant screams hairy, rotten carrion. A blowfly's dream come true.
While the flies might be loving it, the same can't be said for people in certain regions around the world where the carrion plant is being investigated for its invasive potential. In Pakistan, Honduras, Australia, Hawaii, and Venezuela, for example, it's already escaped cultivation. Like milkweed, carrion plants produce seed pods, and the seeds themselves are adapted to wind dispersal, with each individual sporting a tiny parachute.
In 1 square meter of carrion plant, there can be up to 1,500 seeds, and with a 62% germination rate, these plants are more than ready to Mary Poppins down into new areas and start stinking up the joint.
The carrion plant was used by various cultures in southern Africa as a medicinal plant to treat everything from hysteria to pain and to induce vomiting. Currently, it's being pharmaceutically investigated as a potential appetite suppressant.
And I think it's working because just talking about this stinker is making me wish I skipped brunch.
Despite their stink, carrion plants are grown ornamentally by strong-stomached enthusiasts. They're relatively easy to propagate from stem cuttings or seeds. Like most succulents, it's important not to overwater these demogorgon-looking plants.
Just like me, carrion plants cannot tolerate temperatures below 10 degrees Celsius, so just make sure to keep it toasty. And as long as you treat your carrion plant well, it's very likely to flower. In case you want your place to smell like rotting, stinking flesh, this is the plant for you.
Hematophagy, the practice of drinking blood from another animal.
Speculation continues as to who will be the next victim.
These predators are vampires.
300 million years before man appeared on Earth. With time to develop varieties so diverse, their numbers are beyond conception.
For much of the aughts, vampires dominated our cultural landscape. Yet for all their sparkling, headboard-shattering, sleep-stalking charm, they couldn't be further removed from their inspiration in the natural world. There are over 15,000 species that drink blood. Some species drink blood in order to survive or reproduce. These animals are exclusively hematophagous. Others do it as a secondary source of nutrition. They practice hematophagy opportunistically. The earliest known vampires are proto-mosquitoes, and they lived about 220 million years ago. Yet not all bloodsuckers trace their roots back to these mosquitoes. Vampirism has evolved separately at least 6 times in invertebrates. Bloodsucking isn't as straightforward as it seems, and it requires specialized adaptations for the evolutionary strategy to succeed. The first step is finding a host big enough to feed on, and then figuring out how to attach yourself to said host.
Oh, good, it's going in deeper. I can feel it piercing more.
While the method of many of our fictional vampires requires that slow, spooky stalking to find a host, for many vampiric insects it is not so easy. Many of these blood-sucking insects don't even have wings, and have to rely on their hosts and environments for dispersal. Ticks, for example, wait on blades of grass for a host to walk by close enough so that they can attach themselves.
Man's ancient enemy continues to multiply. This tick alone, in a few generations, can give birth to young, outnumbering the population of China.
Batflies also lack wings, and many species have evolved to be hyper-specialized to bats. They're hard and flat, and their legs are covered in little hairs, all of which make it very difficult for the bats to dislodge or kill them. They're born raised, and die, all on bats. Imagine having a tick on your face for your entire life.
Along with ticks and mites, 10,000 species are man's mortal foe. Insect carriers bring death and disease to man himself.
Insects that are able to hunt prey, like mosquitoes, rely on vision, temperature cues, and chemoreception. Tracking CO2 emissions is the most common way these vampires find their meals. Like my dear old gran used to say, if it breathes, it bleeds. Once they've found prey, they need to not get killed. This can be tricky, as the prey of a vampire is often thousands of times larger than themselves. Many insects, like mosquitoes and leeches, inject analgesics to prevent the host from feeling the bite until after they finish drinking. Blood makes a particularly appealing meal because it contains a lot of nutrients, specifically iron, salt, protein, and fat, but it also contains a lot of water. This can make the vampires heavy after feeding, increasing their chances of being preyed upon. Mosquitoes are able to filter out the nutrients from the blood and expel the water, but not all vampires are so adept.
A male mosquito cannot bite or suck blood. A newly emerged male may try blood suction without success.
Drinking blood as a primary source of nutrients is difficult, as it contains almost no vitamin C, and so vampiric species either need to adapt to produce their own vitamin C or be able to get by with much less of it. Mosquitoes are quite possibly the most hated insect on the face of the earth, and that title is very well deserved. They spread horrific diseases around the world, and they ruin the outside. So perhaps it will give you a sense of poetic justice that mosquitoes too fall victim to bloodsuckers. Mosquitoes are targeted by little midges that drink their blood by puncturing their abdomens with their proboscis. Their mouthparts attach very securely to the mosquito and will stay attached for up to 56 hours, through flight and all. If that's not justice, I don't know what is.
The spider spinning his web for the unwary fly. The blood is the light, Mr. Redfield.
Ivarka kulikavora, a jumping spider from Kenya, also targets mosquitoes for their blood. These spiders go after mosquitoes that are full of blood, in part for their nutrition, but also for mating. Jumping spiders that eat full mosquitoes have been found to be more attractive to the opposite sex. In a feeding frenzy, one jumping spider can kill up to 20 mosquitoes in rapid succession. They kill more than they can eat. These jumping spiders are true heroes. Challenging mosquitoes for the title of the worst are kissing bugs and bed bugs.
There's a little bug hiding right in there.
Bed bugs are particularly awful, as they seem to have adapted to feed specifically on humans. These bloodsuckers are particularly difficult to fight because the symptoms of their bites don't show up until several days after they've bitten you, giving them plenty of time to hide. This is compounded by the fact that bedbugs only need to feed about once a week. Like mosquitoes, they inject their prey with anticoagulants and painkillers before biting to prevent their prey from noticing.
So this client tells me she noticed this 2 weeks ago. Well, she may have noticed them 2 weeks ago, but she's had them a lot longer than 2 weeks. See, like they're just friggin' everywhere.
Kissing bugs or vampire bugs are obligate bloodsuckers that are equipped with a huge proboscis to drink blood. They get their name from their nasty habit of biting human faces, as they're highly attracted to the carbon dioxide that we exhale. Vampire moths have adapted their proboscis to drink blood.
Lotta is feeding on me.
It's in?
Ah!
Is it hurting?
Yeah.
Sorry.
The same mouthparts that are used for sucking up fruit juice are used to suck blood from large, tough-skinned mammals like buffalo. Only the males drink blood, and their bites are much more painful and leave a much bigger mark than mosquito bites.
Oh, damn. Okay.
Oh, that proboscis is full of blood.
Good.
It's pink.
Yay.
Yeah.
I'm so glad. Anything coming out of the abdomen?
No.
Nothing.
But the
Okay.
proboscis is pink with blood.
That's really good.
Much more frightening than vampiric moths, however, is the mouth of horrors, the lamprey. 18 species of lamprey drink fish blood, and while they may look like eels, they are actually jawless fish. They attach themselves to their prey using their rows of sharp, horrific teeth, gorging themselves for several days. In order to feed, once attached, they use their hard and sharp tongue to puncture a hole in the fish's body. The fish don't usually die from the wound, but they can develop infections.
For a century, lampreys bred undisturbed in the lakes. No one suspected their potential danger. Then, in the 40s, their population exploded. 400 million years of evolution had done their job well.
Sea lampreys have become a huge problem in the Great Lakes in North America. They've invaded the lakes through man-made canals and have since caused a steep decline in lake trout and other fish populations. All of the vampires that we've discussed today are bloodsuckers, but the ultimate vampire doesn't suck blood, it drinks it. Meet the vampire bat. There are 3 species of vampire bat, and they all use a very different strategy from other vampires. Instead of sucking blood, vampire bats cut the skin of their victims with their sharp teeth and wait for the blood to pour out and pool. Once there's enough, the bats lap it up. As I mentioned earlier, vampire bats themselves fall victim to the vampiric bat flies, and one study found that a single bat can be covered in up to 60 bat flies. And finally, the vampire finch. These harmless-looking birds are native to Wolf Island in the Galapagos, and they supplement their diet of seeds and nectar with blood from the blue-footed booby. Like vampire bats, they make a small incision in the skin of their host, and then they go to town on the blood.
Nothing can stop it now. My dear Anton, this is power.
Understandings are first gained by seeing things at first hand, watching, experiencing.
Metamorphosis.
Metamorphosis.
You know that iconic scene in Jurassic Park? You know, the scene where the T-Rex attacks the kids and